I want to thank you all. We're going to be here with you for 2 days. My name's Al Thomason. We also have here Rick Jones and Tyler and Jason. We're all from Dragonfly Energy. And over these next 2 days, and unfortunately you get me for 2 days, which means you're going to hear me talk a lot and go into rabbit holes. I also definitely want to make sure that you ask questions and get the value out of this. We're going to be covering a lot of material in the next 2 days. We're going to be covering topics such as high energy systems, the Wakespeed 500. We're going to do some deep dives into some of the technical details of the Wakespeed 500, as well as high energy DC systems in general. I was asked to give a very nerdy presentation that'll be tomorrow on CAN bus. And if you guys ever want to learn about CAN bus, come awake. And if you don't want to learn about it, just know that I'm an engineer and I'm the type of person, if you ask me a question, I will give you an answer. Right. So hopefully at the end of these 2 days, you will be able to understand what a high energy system is, high energy DC system is, what is a Wakespeed 500, WS500, and how is it different than other alternator controllers that are out there. We will cover what you need in order to do an installation. There's a lot of options. I brought quite a few of them here on the table that we can look at. We will also be talking about how to configure and install and how to know if it's working, as well as some troubleshooting and some of our experiences over the past 5 or 6 years of doing these type of installs. Things we've learned that go bump in the night. And especially when we talk about 48 volt systems, there's a lot of fun stuff that happens in that world. Along with that, we're going to spill in just a little bit of the Wakespeed folklore and where it all came from, because apparently you guys are interested in that, or at least I was told you were, or at least Kevin's interested. He wants to hear it, so we'll leave it at that. Okay, so before we get started, we are going to, in the way this is structured is it'll be a couple hours of presentation in the morning and then Q&A. I'm guessing we break for lunch, and then afterwards we'll do some lab work. The first day we're going to focus on the hardware aspects of the Wakespeed 500, how you wire it, install it, and then tomorrow we'll go into the configurations. In preparation for that, I want to ask everyone, download the Wakespeed application onto your cell phone. And if you have an Android, that's even better. If you don't, find someone who does. We'll cover why later. But please have that application on your cell phone because it's a very important part of the Wakespeed value prop, not just for configuring, but also as diagnostics tools and going forward. We also have a number of Wakespeed regulators. Kevin, how many do we actually have? We have 5. So, you guys will team up, I guess. Kevin, we'll cover this all when we get into the afternoon. All right. Any questions or comments at this point? Is there anything, I'm just kind of curious, is there anything as you knew that this next 2 days was coming up that you guys were particularly keen on learning about? What's like something that's going, great, I hope I get the answer to? Perfect, yeah. Oh, Kevin's got one, of course he does.
I think one of the things that's going to be extremely helpful for our students is to make sure that everybody understands why Wakespeed, why an external regulator, and probably a lot of detail on the proper installation, because these folks are going to be out there in the field doing these type of things. They're also going to be very involved with recommending to the customer what type of system to put in, so they need to know all that kind of stuff. That's and then of course troubleshooting on the other side.
Perfect, perfect. Well, hopefully we cover a little bit of all those topics. But again, as we go through this, we're here and we're very happy to have been invited in, because we do see a very significant change in the DC systems, the high energy DC systems. It is a fundamental change in the way that boats as well as RVs are being deployed these days. It brings great customer value. It's just, we're not back in the 80s anymore where you just threw a couple golf cart batteries in and called it good, right? So, high energy DC systems. We're going to spend some time talking about what that is. You've heard me say it a couple of times already. My definition is a high energy DC system is when you have an alternator head that's 3 or 4 kilowatts or larger. We at Wakespeed have deployed tens of thousands of these systems. By and large, our systems go with anywhere from 5 to 8 or 9 kW alternator heads. That amount to generate power greatly increases your ability, combined with lithium-ion batteries, the ability to recharge them very, very quickly. That's one of the key values of the high-energy DC systems. To be blunt, generators are going out. Many of our installs either don't have generators or they don't use them, and we'll talk about that in a little bit here on some of the real-world examples. Other characteristics of high-energy DC systems is large storage battery, typically lithium-ion, and although AGM is actually not a bad alternative, to be blunt, I would say 95% of our installs that we see are with the lithium-ion energy storage systems. Large inverters and large alternators, again, all but eliminates the need for AC generation. So why high-energy DC systems? If we look at the marine, and I'm going to mention the RV quite a bit, and you guys are actually fortunate because you're getting this training, and I know as you go out into the world, there is a massive demand in the RV side. Just as a little sidelight, if we go back 20, 30 years ago, the entire RV industry, as you may know, looked to the marine world to understand what to do for DC systems. If you want to know how to install an alternator, go do what the marine guys do, because they figured it all out. That's actually flipped. The bigger demand these days is in the RV world. And because they don't have that fundamental decades-long experience with DC charging, nobody in the RV industry knows what happens if you go and grab that big master switch and turn it off while the vessel's running. I'm sure everyone in the marine world does. You'll get float tested real quick. There is a big demand and a gap in the marine world for skill sets. I'm just putting out an advertisement for you in that respect. So what is happening that's driving all this? Well, like everything in the world, everything's getting bigger and better. We have more electrical demands in marine systems and RV systems. People don't want to leave their comforts. We drove before we got onto the ferry here. We were over there in Coopville, drove through the little park. Big giant fifth wheeler. He had his dish little satellite thing out. He had his little internet satellite thing out. Now, I'm thinking to myself, that's really not uncommon. These people, nobody wants to leave the comforts of home. They want to take it all with them. They want the big refrigerators, the ice makers, they want the TVs, they want everything. And that's driving big demands. Now, we're seeing additional benefits of these high-energy DC systems, such as cooling. Cooling was probably the biggest motivator, again, in the RV world. These little Sprinter vans, they want to have an air conditioner on. And they don't want to listen to a generator running all night to run the air conditioner. So you've got the high-energy DC systems that are able to support the AC. But that's opening up other aspects. We're finding barbecues, we're finding hobs, we're finding in-floor heating. When I fitted out my personal vessel, I tried to remove propane. Just because, one less fuel system to worry about and have to refill the tanks. I worked my hardest. I found we solved the problem for heating. We didn't care about air conditioning up here. There was a solution for the hob. You could get one. What was the stumbling block for me is, try as I might, I could never find a diesel-fired barbecue. So I had to bite the bullet and leave propane on the vessel. But there are now electric barbecues. They'll run off 48 volts or off 110. That's really a lot of part of what's driving these high-energy systems. And the value to the customer, this is what they like. And this is how I actually started this thing myself. My personal trip, maybe 10, 15 years ago, is I don't want to listen to generators. You go out into the world to be peaceful, and you want to sip your cup of coffee in the morning without having to listen to a generator. Or you have your sundowner without listening to a generator. That's a primary customer, that's a second primary customer driver. In addition to all the electric loads, quality of life. And then you can get into aspects of efficiencies and lower costs for maintenance. You don't need an entirely separate engine driving a generator. There's a lot of other secondary values. And as you guys are talking to customers, these are things you'll want to keep in mind. They'll have questions, and you guys, hopefully you'll get a little bit of insight and be able to steer customers with values of why would you want to do this, and is this a good fit for you? I'll also kind of take a step back here. I often get asked questions, should I do X to a boat? My first question is, well, how are you using it? I'm sure you've all experienced 9 times out of 10, people don't have an answer for that. They just say, well, I read about this in a glossy magazine. It sounds cool. I want X. It's like, how are you going to use your vessel? You need to walk down that path to find out if this is a good fit. Increasingly, high energy DC systems are, but it's not universal. You know, you got somebody who doesn't have refrigeration and doesn't have, I mean, there's a lot of people who, they're perfectly fine with a little old golf cart battery. Perfectly good system, nothing wrong with it. So I'm sure you all know that, but that's just kind of some of the life lessons that we have learned. And we also hear numerous times from customers saying, I want to do X because it sounds good. And then when you talk through it with them, you find out it's maybe not a good fit. And they're not willing to take all the steps necessary to do it safe as a system design. Okay, is there any questions at this point about what a high energy system would be and maybe the components that go into it? We're going to cover a little bit more in depth on this. I just want to make sure I'm not going over stuff that you really already have a good handle on. Okay. All right, I'm getting a thumbs up from Kevin. All right. One example of a high energy D system, large house storage bank. This is the legacy 12, in this particular case is a 48 volt install. Legacy 12 volt install, you still have a lot of legacy 12 volt equipment, or 24 volts sometimes you run across in the marine environment. We've got a alternator charging system controlled by Wakespeed. You've got your large inverters, you've got a bunch of solar panels. This is very representative. And also notice the servo at the top for the monitoring. That's another expectation customers are having more and more. So this is take away or put in, very representative of what a high energy system is. And we've covered a little bit about this. How does it work? You need to optimize for your loads. Typically what we find, especially with these split voltage systems, and I'll also put a little advertorial in. I don't know what percentage it is. I'm looking at my partner, Rick, but I'd say 60% of our deployments are 48 volts.
Yeah, I'd say so. You know, on the marine side, maybe 10%.
Yeah.
But in general, about 60%.
Yeah. Marine hasn't really crossed the 48 volt world yet. And part of the reason is, to be candid, they got 24 volts, so they don't quite need it. If you start with the 12 volt world, it's all but impossible to do this. 24 volts, we have a number of deployments to do it, but 48 volts brings a number of good advantages. So the demands for electrical loads, largely air conditioning is what's driving these type of systems. You need to consider not just what the static loads are, but the nominal loads, the little small guys, the refrigerators, the lights. Those guys are still at 12 volts, or in the marine world, 24 volts. And we don't see those changing anytime soon. So as you move forward in this, unless you have a pure 24 volt install, which does happen, you are very likely going to find mixed systems. And that induces some complexity that has to be considered how to solve it. So one of the first things you want to do is start with what are the loads and what voltage system is best applied. High wattage loads, high energy loads, move to 48 volts. Here, do it directly if you can, or through inverters to do 110 AC. All the legacy stuff, the light bulbs, frankly, light bulbs probably won't go to 48 volts, and there's reasons for it. They'll probably, 12 volts will be around for a very, very long time. You need to consider not just the static loads, but also the surges. So if we look at sizing generators, a disadvantage of generators is you have to size them not for the ongoing load, but for the peak and the startup load. So if you've got an air conditioning system that draws 4 kilowatts nominally, you may have to have an 8 kilowatt generator just to do the startup surge. And there's also aspects of what the actual quality of the AC power coming out of the generator that comes into play here. But the bottom line is, with generators, you have to size for the surge. When you're sizing with a high energy DC system, you have to size your inverters for the surge. That still has to happen. But one of the big advantages of the DC systems is the efficiencies. When you size an AC generator, an 8K generator that has to run at either 1800 or 3600 RPMs because of frequency demands, it is very, very lightly loaded, right? and that produces some efficiencies, which we'll cover in the next slide. But when doing high energy DC systems, what you want to do is you want to look at the surge loads. That's going to tell you what your inverters are. You want to look at how long this person wants to be able to run without running a generator or the engine. That's going to tell you how big your battery bank is. I mean, pretty intuitive, but you'd be really surprised how many people don't even take that simple step when looking at stuff. Okay. I talked about AC generator efficiency. Yes, sir?
I got to stop right there just for a second.
Yeah.
Can you help us, where is the best place to acquire this surge load information on our products? Because many products today, as you well know, do not give us that information on the box or in the directions. You have to really do a lot of digging.
So my stock answer is always contact the manufacturer. But as you pointed out, that often doesn't help. In the real world, the thing that's the most critical is anything with a motor. And there's something known as lock rotor amps. If you can't find a spec, and I'm going to look for confirmation because I'm going out on a limb here, I would say if this thing says it draws 10 amps, just plan on 20 amp surge. Does that?
I think that's a pretty good rule of thumb. Just we're going to double whatever that amperage is for the first few.
If they're not going to tell it to you, yeah. Now, the other aspect of that is also what the inverter can take. And this is another, I'll just be frank with you, this is where you have to just try it and learn. Because manufacturers on all sides of every coin lie. I'm sorry, they publish specifications for you to study. On my personal vessel, I've got an AC compressor that I use for the air horn as well as a hookah system. It specifies what the lock rotor is and it specifies what the surge is. I also have an inverter that matches that requirement. It doesn't work. I had an inverter from one brand that worked great until it stopped working. Then I went to the glossy magazines and bought an inverter that was highly recommended and it met the specifications. It doesn't work, so I had to go out and buy a larger inverter. So unfortunately, there is no definitive way to answer that particular question. I'm sorry. If you're going air on the high side, like everything in the world, you don't want to be running them at 90% of their capacity, 100%. Try to, oversize, go one size bigger. And that's how I've gotten through. Like on my Anchor, for example, I actually went 2 sizes bigger, and I sleep well at night. So do the same thing when sizing, okay? I want to talk a little bit about fuel efficiency. My wife and I, we retired early. We sold everything and we moved on to Old Monk wooden trawler. During that time frame, we had the opportunity to move back to Minnesota to the family farm with my wife's folks as they were taking care of their aspects of life. And I got time to spend time on the farm. I actually have driven the combine, which I guess is a massive honor because most farmers, when they plant seeds, they want to drive that combine. Well, Dean, who now owns the family farm, it's a dairy farm. He said, you're more likely to scare the cows than you are the combine. So you do the combine, and he did the cows. So that's how I got to drive a combine. But one of the things I noticed in there's a reason why tractors have got like 96 gears. And that's because every single engine in the world has, and this is a very simplified view, every engine in the world has an RPM, horsepower, and efficiency curve associated with it. And the idea is you want to be operating up at that 100%, 110% point. You want brake fuel consumption, BFC. You want the most output, usable energy output from your engine for every ounce of fuel you put in. That's why tractors have got 96 gears. Because when you're going through hundreds of gallons of fuel a day, the difference between gear number 82 and 83 can make a difference. And here's the problem with AC generators. When you fully load them, this is just an example, when you fully load them up at that blue star point, you're doing pretty good. You're on a curve that we're just going to call 100%. Now, if it turns out that you could reduce the load on an AC generator a bit and come back to this point here, right, you'd actually get better efficiency. Have you ever heard this phrase that you want to size everything for peak torque? It actually turns out that that little 110% happens to kind of coincide with the peak torque of an engine, on most engines. So the point being that you want to be largely on the output curve. Now with AC generators, when you only have them, say, half loaded, when you're only doing 50% of the output, you're over here where the red star is. And guess what? You're now down at 75% efficiency. You're burning, if you do, you see changes, you're burning more than 25% more fuel. And actually, most AC generators are even loaded even lower. So they'll end up burning 2 or 3 times the amount of fuel necessary for the typical load that they're presented with versus if you had them fully loaded. And this is where a DC system comes into play, because an AC generator, unless you have one of the fancy inverter ones, which is actually a DC generator with electronics behind it, has the inverter built into the generator, the AC generators have to run at this fixed speed. You have no choice because you have to maintain the hertz. Whereas with a DC system, if this is all the power you need, well, we'll just slow the engine speed down and we'll get back up into that 100%, 150% efficiency. A lot of people don't think about this. This is something that isn't, it takes quite a bit of brain power to get behind this and kind of do the math. And I know every time I look at it, I have to puzzle quite a bit. But again, I'm going to come back to my personal vessel. I built a DC generator and I did the math and I figure that I burn 1/3 the amount of fuel to run my DC generator because it varies its speed and it's always on this high efficiency curve point versus if I'd use an AC generator. So when you're talking to customers about high energy DC systems, this is actually a good point to bring out. Now, there is an unfortunate corollary to this that if you're running a big giant engine, even at idle, just to drive an 8 kW head, well, guess what? You're not up on the curve. However, if you have your vessel underway or your van is underway, it's already well up on that curve. The reason cars have got 8-speed transmissions now is so they can get back up on that curve. So when you apply that extra 8 kW load to a vehicle that's in motion, you're going to be doing very, very efficient fuel burn rate. Is there any questions on this? Have you guys seen this before? Have you even thought about it? Have you been exposed to this before? Okay. Yes, sir.
Back to the earlier comment you made about the sizing of generators,
Yeah.
the inrush current of all the conceivable loads.
Yeah.
It just seems like we've got a built-in problem here with the fixed RPM of the generator,
Yep.
the power curve of any internal combustion engine that's converting chemical energy into mechanical energy, the goal being universally fuel efficiency.
Yeah.
And so where I'm sort of sensing you're headed with this is that when given a choice in a marine application with high loads, a lot of systems, a lot of demand, between a generator and all of its maintenance and all of its engineered-in limitations, that the higher capacity DC system is preferred.
It's a great value, and obviously we have a vested in. Sorry, I grabbed my mic. That guy just went. We obviously have a vested interest in this because we're a key player in this space. But when you look at how things were done 40, 50 years ago, and fuel cost 20 cents a gallon, nobody really cared, right? But fuel ain't 20 cents a gallon now. And that's just one aspect that makes a 50, 60-year-old architecture less desirable, the fuel efficiency. AC generator is going to burn, I'll bet, 2 to 2.5 times more fuel than a comparable DC generator system would, hands down, just because of this. Now you've got all the maintenance issues associated with a lightly loaded engine and low cylinder compression and glazing in there. And then you tie in the cost associated with just buying it. You'll often find that putting in a high energy DC system is less expensive than putting in an AC generator. And you've got the ongoing maintenance cost with it, right? So
Engineering inefficiencies, no one's going to have control. You can say, oh, well, I've done a load assessment on, and I've interviewed you about your use pattern, boat owner number one or whatever. And yeah, based on that data, I can, from an educated place, choose the optimal generator, but I can't overcome the inefficiency.
you'll never overcome that. And it's because it's a fixed RPM. Now, having said all that, I remember early on, there was a slip mate of mine down in Portland that would come up every summer. He had a big 65-footer and, you know, one of the classic boats that you'd find running the generator, if not 3 in the morning, 3 in the evening, sometimes 724. What he did is he got one of those little Honda generators. And it's an AC generator, but think about it. It's really a DC generator with an inverter, all built in. He'd get one of those little Honda guys, he'd throw it on a swim step platform and bungee cord it on so it didn't go in the water, he hoped, and run an extension cord, and he actually bought a little 20 amp charger. And he hooked that up to his house battery, and he just had that thing purring along all the time. My wife and I, we actually did that for a little while, and then we kind of figured out that we were getting killed by the exhaust because it's a generator bungee cord to the swim step, right? Which was a horrible idea. But you're exactly right. You will never, this is a physics thing. You can't get past this. And then when we add all the other potential values, this is why we're seeing shifts. And you're going to hear me talk a lot about the RV industry because by and large, most of our sales have been in that space. It just has been. They've had a forcing function. These little Sprinter vans, they ain't got a lot of room in them. So there's a benefit to not dedicating that space. So that was an additional motivator. But let's look at some examples that don't have that room constraint. This is probably one of our first installs of a high energy DC system. Used MG Energy is the brand. Yes, MG Energy is the brand. Yes, MG Energy is the brand. Really large. I mean, this is like 6-figure installs, right? I mean, when you've got a boat that costs a lot more than 6 figures, you don't mind 6 figures into the boat. But really, really interesting person. They take this vessel north of the Arctic Circle. Rick, I mean, you know a little bit more.
Actually, there was a really interesting article in Passage Maker magazine about this boat. It was written by Steve D'Antonio. Yeah, this boat has gone further north than just about any other, individually owned recreational vessel anywhere. This has spent more time in places that nobody else goes, and that's part of the critical nature of getting the electrical system correct, because there just aren't technicians north of the North Pole.
There's no beaver planes that show up to bring you spare parts, right? My wife and I had an opportunity to spend a few days with them on their vessel, and it was just wonderful to see the photographs that they had. Just, if you're the type of guy or gal, sorry, if you're the type of person who likes to go cruising, I mean, this has got to be like, wow. He actually has done a couple of the Northwest Passages as well. Things are opening up. The thing that I like about this is this quote from him. He now has to look for reasons to run his generator. He's got a large battery bank, fairly large, 2,200 amp hours at 24 volts. That's a pretty good sized battery bank. He doesn't ever have to run this generator. They'll pull up anchor and they'll move, and in 2 hours, they've recovered all of their energy that they use. But his challenge is that he runs out of water. And he was angry with me they ran out of water because he didn't size his inverters large enough to run his water maker. So that's why he has to run this generator. But here is a perfect example of a high energy DC system. This has a single engine, single screw, They put 2 alternators on the same engine with 1 Wakespeed controller managing it, and he's one of our first examples. This is another example, and again, this was with MG Energy System. This is, we think, the first recreational trawler, large power vessel, not a sailboat, but a large power vessel that made a passage to and from Hawaii without ever running their generator. This is a vessel that had the washer dryer, had the HVAC, had the water maker running, had the refrigerators, the air conditioners, the stoves, everything running off of AC power. They never started the generator. And what's really interesting about this one is this had 2 battery banks. This is actually a value that Wakespeed has that we'll cover in a bit. We have the ability to aggregate multiple battery banks. During this passage, the battery bank in the bow, a cell went sideways. And that BMS took that battery bank offline. But because of the communication of the Wakespeed recognized that, readjusted the entire system's parameters, and carried on the voyage with just the battery and the lazarette. The only reason the operator knew about this, because nothing changed in terms of their operations, they didn't have to turn off their refrigerator, they didn't have to stop taking the jacuzzi baths. The only reason he knew about it is the guy was curious, he did his little cell phone app, and he noticed that forward battery was offline. This is one of the key values of these high energy systems, and I'm going to use the word system a lot because it's a very, very important concept. A little bit, another example showcasing some of Wakespeed's capabilities. This particular system had, again, a primary engine with 2 alternators on it. Oh, yes, ma'am. Sorry.
Yeah. So before you began your talk, I thought that Wakespeed was just a kind of external regulator. I'm now gathering that it is not that.
It's a lot more than that, yeah.
So could you, as you're getting into some of these details about the value to the vessel, and I don't doubt that you'll elaborate later, but can you just give like a quick overview of
Sure.
what the system is?
Sure. So just to cover your question, yes, we are definitely going to go into detail on this. The Wakespeed is different than traditional external alternator regulators in 2 ways. 2 primary ways. There's a number, but the 2 big ones are we're more than a voltage regulator. We actually monitor and manage battery voltage, battery current, we're a current regulator. Alternator temperature, we're a temperature regulator. We can also manage system load. So when you put an 8 kW head on an engine, there may not be enough guts in that engine at certain RPM, so we can actually pull back so that you don't overload. So we take into account the battery subsystem, we take into account the alternator, and we take into account the chassis. Those are 3 primary, or those are kind of the big differentiator of the Wakespeed. It's in the middle of all of this, and that's why we become kind of I want to say a critical component, because we're touching all these things, we're taking all this information in and making decisions, all right? By the way, that'll come up again later, because we're also the blame for anything that goes wrong, which we'll cover that in a bit. Does that answer your question? Okay, thank you. All right, another example, this particular vessel, this used, the reason why I put this one in is that this vessel is, again, a Nordhaven. We've done quite a few large Nordhaven installs, as you can tell. This one was lithium-ion batteries. We, again, had 2 alternators on the main, but then also on the wing, they put a large alternator on the wing. Now, what's interesting about this is some of the capabilities that the Wakespeed has the ability to prioritize. So when we're looking at how to charge the battery, we can prioritize who should work harder. In this case, they said, work the wing harder. So if they happen to be running the wing engine as a DC generator, they want to load that engine up. Remember we went back to the fuel efficiency curves? They want to put as much load on that guy. So we'll back off the mains and we'll load up the wing. That's one value that was demonstrated on this vessel. Another value that was demonstrated on this vessel is that wing engine also drove their primary hydraulic pump. And this particular vessel had hydraulic bow and stern thrusters. Every time they hit those thrusters, the engine load would go to like 90 or 100%. Well, if you're pulling out 70% of the engine load through the alternator, and then you hit a thruster and you're now all of a sudden at 170%, you can guess what's going to happen. The Wakespeed regulator is able to detect that. And when they hit those thrusters, we see the engine load go up, and we would back off the alternator so you didn't overload the engine. We'll get into that, how you go about doing that, probably tomorrow. But the reason why I put these three examples is because they showcase each one of them in a different way, the values of high energy DC systems and the values of the Wakespeed Alternator Regulator. You have more efficiency, better quality of life. I'm annoyed because I have to find reasons to run my generator, right? You've got auto fail-safe and redundancy. I'm a licensed captain. When we went down to Reno, because they don't know anything about boats, they're learning. Rick and I are teaching them. You know, they're kind of wondering, well, why are you guys so careful? It's like, because there is no AAA, and because if things catch on fire, you can't just step out of your vehicle, right? So we are hypersensitive. I am hypersensitive about failure modes. And it reflects in the product we have built and reflects in the design choices we have made. So we've got redundancies that automatically will come into play and not require human intervention, which is notoriously unreliable to recover from issues. And then we've also got examples of this whole prioritization and how do you make your system work well. Again, and I still have so many people call up and doing installs where they've mounted 5 or 6 toggle switches on their dash because they want to be able to do this, this, and this, this. That's fine if you want to do that. You can, but you don't have to, because carbon-based control units, people, are horribly unreliable. So that's why I've showcased these three, because it illustrates different aspects of the Wakespeed Alternator Regulator and what values it can bring to the table, providing it's installed and configured correctly. Now, they're not all these giant 6-figure installs. This is an example of a vessel I just visited here a few weeks ago up in Roche Harbor at the Celine Rendezvous. They had done an install. I'm sorry, I'm proofreading this to make sure I didn't leave anything in there. You guys are the first ones to see a slide deck, so if there's anything goofy, I apologize. They had done an install with a modest lithium iron phosphate battery. They don't have air conditioning. They have to have heat, and they run a diesel, fired heater for that. And their great benefit is they used to have to run the AC generator underway because the ship's load underway exceeded the output of the engines. It just couldn't keep up. They also ran the generator every day at anchor. And now, neither of those things they have to do. So they're very happy. So their primary improvement was quality of life. They said, it's great, I don't have to listen to that bloody generator anymore. And just so you know how much I hate generators, my cruising style is we'd be heading north by now, and if we saw people, we'd go more north, and I carry a bag of potatoes, because I found there are a number of boats that actually have got a problem. They leak. And they usually leak for a couple hours every evening. And I found if with a potato, you've picked the right size one, or I'll just go over and plug the hole for them, because I don't want their boat leaking, right? And it solves that particular issue. Sometime later they have other issues, but at least I've solved that one, right? And I hope you understand what I'm saying, and no, I don't really do that. Except that whole aspect that when I see people, I go further north. Yes, I do that. Now, one last example I'm going to give you is a very, very modest install. This is a 60-year-old wooden trawler, happens to have, or had, 1,400 amp hours of lead acid batteries. They were forklift batteries. Could sit at anchor for 5 days. Didn't have air conditioning, modest refrigeration use. We had supplemented with solar panels, a couple of inverters in there. This is actually my personal vessel. This is actually where the Wakespeed all started out some 15 years ago, the Wakespeed technology. This is where I learned what works and what doesn't work. My wife and I, and maybe we'll talk a bit more about this in a bit, we actually retired early and sold everything, and that's all we owned. And our cruising lifestyle, we came in, stayed in Friday Harbor for the winter, sometime October, November, when it turned rainy, and supported the coffee shops there. And then in the spring, as soon as I could pry my wife off the dock, we'd head north. And she actually found that if she cleaned the dock lines, she could get an extra 2 or 3 weeks out of me because she likes coffee, right? But nonetheless, we were away from the dock 8 months plus out of the year. That was our cruising lifestyle. We'd come in once a month for provisioning, and all the rest of the time we were self-sufficient. So high energy, early example of a high energy DC system. It still makes sense today with lead acid batteries, although the Wakespeed predominantly gets deployed with lithium ion. For this next hour, we're going to do a little bit of a dive into the components of a high energy system. And I understand you've covered some of this, but I was asked to go a little bit more, kind of sharing some of our lessons that we've learned over the years. So the first thing we're going to talk about is, as I call it, the spinning rust. Alternators, an overview. So this goes back into a little bit of history, and I'm seeing some people out there that might understand some of this. If you've ever seen a generator or a dynamo, and if you understand the difference, there was, how do I want to say this? As time moves on, there's often something that forces a change. And we're focused on the DC systems here. So in the 50s, that thing that focused a change was increased electrical demands. People wanted not just headlights in their car, they wanted 2 headlights. They wanted a radio. They wanted a heater. They wanted a heater with a fan. Good Lord. They wanted all of this electrical gear in these fancy new cars. And the DC generators, which actually made DC, and we can talk about offline the difference of how it did it, they weren't up to the task. They could not scale large enough to make 20, 30 amps. They just couldn't do it. That was kind of their high water mark. So the auto industry, being clever people, said, let's figure a different way. Alternators. An alternator is actually an AC generator. It's an AC head. Alternator consists of the stator. That's the thing that produces the power. It produces AC power. It then goes into the diode pack, which rectifies it into DC, which gets squirted out to your trip hazard, gets squirted out to your battery. These fancy things. I like to walk, but thank you. And then the way you control it is there's a rotor, and that's actually an electromagnet. And that rotor has got the field in it, and that is controlled by the regulator, which in this case is here. And how hard you drive that electromagnet, how hard you drive the field, combined with how fast the alternator is spinning, determines how much power comes out of the alternator. That's just fundamentally how they work. When we look at from a modeling standpoint, we actually look at these things as mechanically driven current amplifiers. We put in a certain amount of current into the field. There is a multiplication factor that is variable depending on how fast the engine is going, and that's how much current you get out the back end. And those of you who all know Ohm's law, there is relationships between voltage and current, but when we're looking at these things from a modeling and simulation standpoint, they're actually modeled as a mechanically driven current amplifier. Okay. By the way, in case you're all wondering if you've ever had tach driven off the alternator, that is sensing the stator. It's sensing the AC waveform before the diodes. That's why it's called the stator tap. And they're looking at the frequency of that AC because we're not at a fixed frequency. We don't have to make 60 hertz. We vary the engine speed up and down, so you get a variable frequency. That's how those tach-connected alternators work. Or, sorry, alternator-connected tachometers work. Which, by the way, and I'm sure everyone knows this, is why the customer complaint, my batteries are full and my tach stopped working. What's wrong? You don't need the output of the alternator. You're not putting any input into it. You're not getting any AC waveform, and your tach just stops working. All right. Here is a bit more detail I've already covered a lot of this. This is an example of what would be inside many alternators. You've got the stator and the rotor. You've got slip rings. And the cool thing about this, and this is the biggest differentiator between a DC generator or dynamo and an alternator, this is a fairly low current path. With the DC generator, they actually rectified using slip rings, and they had to run that 20 or 30 amps through the slip rings, and that was the limiting factor. You just couldn't do it reliably. So in this case, when you see the rings, they're actually driving the rotor, fairly low current, maybe 2 to 4 amps, depending on your alternator. We've had some that are as high as 20 amps, I think, but that particular alternator weighed about 600 pounds, and it had an 1 3/4 inch shaft that got twisted off during operations. And I'll be happy to cover that little story at time if we have opportunity. Voltage regulators, most alternators, we have to remember this, most alternators are made for the auto industry. The auto industry, all they gotta do is supply a little bit of power into the battery and run the fan and the heater and the lights. So their whole job is to run the fan, the heater, and the lights, and they use the internal regulator because it's just quicker that way when you're building bazillion cars, and that's how, where'd that little red guy? That's how factory-mounted alternators come, internal regulator. We're obviously using external regulator, and we'll cover a bit why later on. Every alternator is going to have a diode pack. You may hear at times something called a diode trio. They're not common, but some alternators use them. That's an independent diode pack that's very much smaller that feeds into the regulator. Can anybody guess why you would have an independent diode pack feeding into the regulator? I'm not trying to bait you, I'm just trying to engage you and wake you up a bit. The reason why is every time you run current through something, you're going to get a voltage drop. And it's always, not always, never use absolutes. It is almost always going to be, that voltage drop will almost always be dependent on the amount of current you run through it. Diode pack's no different. The voltage regulator uses this diode trio independent in order to sense battery voltage. Senses the battery voltage inside the alternator. And by using a diode trio, you don't have the variable aspect if you're putting out 10 amps or 110 amps interfering with the ability to sense. That's why a diode trio exists. So if you ever are modifying alternators and you hear this thing diode trio, you'll probably be one of the smartest people in the room unless you happen to go and find a competent alternator shop with a guy that has hair colored like me. They'll know why it's there. Okay? One very critical aspect of alternators that I want to talk about is the data sheets. Now, we talked about the data sheets, liar papers. We talked about the data sheets before, right? You have to understand what data is being presented on the alternator. Most alternators will be sold as voltage and current. That current delivered will either be obtained only at a high point or never realistically attainable. The reality is alternators have a function of their RPM that we talked about already, but also their temperature. As alternators heat up, resistance increases, and it means that losses inside the alternator itself is going to reduce the output. So this is where the data sheets are really important. And a lot of companies either won't publish these or they'll publish them and not tell you what the temperature curve is. Or you can get quality alternators that will actually tell you what the parameters are that they measured under. So here's an example of an alternator that is sold as a 130 amp alternator. Actually, I'm not sure they call it 130, it's their 130 series. I have to admit, I'm not sure what they spec this alternator at, I have to admit. But at cold, when you first start that alternator up, it can produce, and you wing it really fast, it can produce almost 120 amps. But that's not real world. Within a few minutes, that alternator is going to warm up. and you're going to be down to well under 100 amps. So this will come back a little bit later when we talk about the value of the Wakespeed. As alternators heat up, their ability to produce amperage declines, and they can decline dramatically. The other aspect is how fast you spin them. So when you're sourcing alternators, you want to understand this. You want to know heat is the enemy. You want to know what the alternator is actually going to produce in the real world, and especially the worst case examples we've ever ran into are sailboats, because sailors hate their iron jib. There's just no one out there that has any love for it, so they stuff it in a little small closet. You know, it's really hot, it's cold, it's miserable inside there. That's going to really be an issue. So make sure you look at what the warm, hot temperature output of the alternator is. The other thing you go on to look for is what its output is at lower RPMs. If you have somebody that's looking to do recharging of batteries while at anchor, just doing a high idle, you need to make sure you get an alternator that has good output at lower RPMs. So I will clue you in. This is a 48 volt alternator. One of the Achilles heels of 48 volt alternators is they have lesser output at lower RPMs. You have to spin them faster. The entire industry is working on it. We have a couple of strong partners. We know they're continuing making improvements. But as you're going through trying to figure out how to design your system, just be aware of that. The 48 volt alternators today, that's probably their biggest Achilles heel. Yes, sir?
So on that specific topic, not that I've been exposed to or encountered a request for 48 volt alternator, but is the primary strategy for that belt and pulley ratios?
Yes. Yeah. That is, I'm really glad they brought that up. So the answer to this is you do your belt and pulley ratio, and you want to have the alternator spinning. I'm not sure, if this thing's rated 8500, I'm not sure I'd try to have it spinning all the way up there. But you want to have it spinning where it's moving fast. That's where the alternator is going to be its most efficient. It's going to have its best cooling. You're going to get the most power out of the alternator.
Basically analogous to the power curve, the internal combustion engine.
It is.
Optimize the speed of the alternator in this case.
Yeah.
And then on thermal management, that's a wild card because as we all know, in a marine engine room, it can be adequately ventilated, rarely, but if it's well engineered, sure. It can have active, ventilation. It can have passive ventilation. It can have totally inadequate ventilation where the ambient temperature of the air that the fan that the alternator is turning to cool itself is too high for it to really do a good job.
A lot of variables, absolutely.
A lot of moving parts there.
A lot of variables. And
2 alternators on one engine and
yep. I was going to save this for tomorrow, for the end of tomorrow, but I'll go ahead and give this account. We got asked the question earlier, what makes Wakespeed different? One of the differences is the Wakespeed regulates alternator temperature. We don't wait for it to go over its limit and cut back. We'll actually do that. That's like our second or third step. But at first we try to regulate it. Customer complaint from, I forget if it was South Pacific or Southeast Asia, hot, humid area. What's wrong with this Wakespeed regulator? My 160 amp alternator is only putting out 48 amps. I need a new regulator. This thing's broke. Well, and this is why it's going to be tomorrow, because we're going to talk about things you're going to find going on in bump in the night and how to address them. We have them capture our log file. Another value of the Wakespeed. We can produce log files. We looked at how that system was behaving. It was rising 1 degree every 2 seconds. Because the Wakespeed is an active regulator, we recognize that the rate of change, the dt, delta temperature over delta time, was excessive. We started backing off. We took our foot off the gas on that alternator when it was at 65 degrees C. It was set for 120. We did overshoot. We went to 121 degrees, and then we lay it out at 120, and we could produce 48 amps under those conditions. So what was wrong with the Wakespeed regulator in that particular case is we kept you from burning up your alternator. That's what it was. The solution, they moved their engine air intake hose a little bit more toward the alternator to get a little bit more cooling. Now, of course, you got to be careful with that, you know, the engine compartment vent hose. You have to be careful that, especially in a marine environment, you don't want salt air blowing straight on things. But it was a lack of cooling. And the Wakespeed regulator did what it was supposed to do. It kept it from burning up. Have you ever seen that film that Victron has made about burning up an alternator? Well, you might be able to see it. They take an alternator with, you know, there's some, I think I told you I finished my career in marketing. So trust me, I get about this, but I also have a technical background. There's some sleight of hand going on in a lot of those videos you see. None that will come out of Dragonfly, by the way. We were all straightforward. And no time did my fingers leave my hand, right? But yeah, it's not a joke. And in the marine world, we see this more in the marine world than anywhere else, and especially on sailboats, because there's just chronic poor ventilation in the engine room. And those poor little alternators are just being hammered. So another thing, and again, Rick's the smarter guy on the spinning rust, different alternators have different ability to cool. There's multiple fans. There's all sorts of kind of fun, interesting things, okay? Any other questions on alternators? Yes, sir.
Yeah, like where does Wakespeed get its temperature reading from? Does it have like a separate external
We do.
temp sensor? Okay.
We do.
So it doesn't rely on whatever comes in stock.
All your harnesses, for the alternator, all your harnesses will come with a temperature sensor, and you want to mount it somewhere on the alternator. We'll cover this a bit. If that's, I'll go ahead and do it now. In alternators, the most vulnerable component is the diode pack. So our experience is get the temperature sensor closest to the diode pack as you can. I personally, on my personal vessel, I've got a Leesonville 4800 series alternator that's like 35 pounds. It's J1AA mount. And the diode pack's right there on the back. I mount my temperature sensor on the diode pack itself.
So is that what burns out when people say an alternator burns out? It's a diode pack that burns out? Or?
Typically, yes. That is the most vulnerable part of an alternator, absolutely. They'll get worried about the coils getting hot, but the varnish on the coils are very, very high rated and stuff. Yes, sir, I saw.
So can you actually put it on the battery, on the alternator output, on the positive?
That's the second best. If you can't get the diode on the diode pack yourself, like this one you can't. Well, you actually can, because this one got the plastic decorative cover got damaged in shipping, and you know, that's actually the diodes there. But there's no way around it. So the next best place that we have found is place it on the positive output post. So put your heavy current cable and then stack the alternator temperature sensor and then stack your nut. That's the second best place to get to the diode pack. But no, in that case, that heavy copper wire is pulling some of the heat away. So you might want to derate the temperature setting a couple degrees to account for that.
And it's all configurable inside.
Absolutely, it's all configurable. Now, there is one significant delta to this, and this is Balmer. And I'm not, you know, Balmer's a great company. They did some very wonderful things. Their technology just, yeah, anyway, Balmer's a great company. We actually recommend Balmer alternators a ton because one of the issues that we often happen is when people try to take engine mount alternators and convert them for external use and try to drive battery banks, that often is problematic. So by just saying buy a Balmer, I don't have to deal with that. I know it's going to work. But the Balmer, and this is something you need to know. If you look at the Balmer often has on their case a boss, a little screw where you mount the temperature sensor. And then if you go and study the data sheets from Balmer, at least when I study them, it says 83 degrees C. So when we configure for Balmer alternators, we specify 83 degrees C. This point is halfway between the diode pack and the stator, right? So it's picking a little bit of the best of the worlds, and it's a consistent way across their whole product line. So just be aware of that. There's a direct relationship between where you mount the temperature sensor and what temperature point you set it for. The stator, by the way, that big guy I was talking about, it's got an exposed stator. That thing, the alternator itself, I run the diode pack at 95 degrees C. I think they're rated for 120, 115. The stator itself will often go to 180.
Yeah, you can see 100 degrees difference between the stator stack and the rectifier.
Yeah. And we have consulted with Presto Light on this. They're not alarmed. They say, that's what it does, that's what it's made for. We did that because a lot of customers, not a lot, I mean, they're really inquisitive customers. They were noting the different temperatures and saying, oh man, that's so hot, that's too hot. Manufacturers don't specify what that temperature should be. I'm not going to share all of that email, but we had direct engineering to engineering relationship, and it's not an issue. The alternators are designed for that. So bottom line, yes, where you place the temperature sensor matters, and how you configure the regulator is dependent upon where you place the temperature sensor. Okay? All right. I want to talk, and we're going to come back to alternators as we go through this, because that's obviously an important part of this, but just wanted to make sure we covered a lot of the basics. I want to talk about some of the systems approaches. You're going to hear us over the next day or two talking about these high energy systems. And you know what? It's not for everyone. There are a bazillion ways to hook up a boat. I mean, if you go way, way, way back, you know, you had the starter battery and a diode-based splitter and the house battery. And maybe it was a couple of Group 31s or a couple of golf cart batteries. I don't know. Those are perfectly fine if it satisfies the needs of the customers, right? In the world we live in, this is my recommendation. This is how I categorize stuff after I've asked a customer, how are you using your boat? The simplest and easiest, leave the factory alternator in and don't change it. Have it connected up to the starter battery and get a DC to DC converter. Victron makes like wonderful ones, 20 amp ones, they cost 180 bucks. Get a DC to DC converter, configure it for the needs of the house battery, and it'll charge the house battery appropriately. And I think that is a very, very appropriate install for like 20 to 30 amps. So we're talking 500 watt generating power transfer capability, right? There are other approaches. Yes, ma'am.
What is the DC to DC converter charging?
The house battery.
And what's charging the starter battery?
The factory. Yeah, you make no changes to the engine. You don't change the alternator, you don't change the starter battery, you touch nothing. You get that little Victron DC to DC converter, you put the input to the starter battery, you put the output to the house battery, and there's a enable wire that goes up to the key switch. Now there are other ways that people do. They used to use relays, they used to use FET, they used to use diodes, they used to use all sorts of stuff. I don't particularly like those, and here's why. Having a DC to DC converter that is configured for the needs of the house battery, and the charging needs of a house battery is dramatically different than the charging needs of the starter battery, which we'll cover in a bit. Having a DC to DC converter that can do what the battery needs, the house battery needs, totally independent of what's happening on the starter side, is the right answer. And these things are only 200 bucks. Don't go spend 150 bucks that's going to force the house battery to be treated just like a starter battery. That's the wrong answer. Spend the extra 50 bucks, have a simple, reliable system. Absolutely perfect for 200-300 watts. I saw a question back there.
Yeah, on top of that, you can have two different types of batteries that way.
Yeah.
And charge them correctly.
Exactly, exactly. Yes, sir.
I just want to clarify again, this is a low amperage system.
It is a low amperage system.
It's just like a sailboat that is being used on weekends to go sail.
This is a low amperage system.
That's going to be needing a lot of power. I just want to make that distinction.
Yep, 20 amps. You're going to hear me flipping back and forth between watts and amps. I know the boat industry stays with amps. You're going to see over the next 5-10 years a migration toward watts. So I'll try to use both terms. But yeah, this is a 20 amp solution. You can do this with a 200 amp, 250 amp DC to DC converter. Wakespeed offered a product called the Wakespeed 3000, 280 amp DC to DC converter. We deploy those on like Ford trucks that had twin factory 280 amp alternators and a 48 volt battery. You can definitely do that, and there was reasons for doing that. But if you're going to go and buy 4K watts of alternator head and spend a lot of money on it, and then buy another 3 or 4K watt DC-DC converter, why? Why not just have the alternator heads talk straight to the battery? So I don't believe this architecture scales, my personal opinion. I think it is brilliant for entry-level systems. Yes, sir?
If you're doing 200 to 300 amp hours, if you've got a couple of group 31s for your house bank, you know, you've got a 60 amp alternator on the engine, that's a perfect solution. You know, just throw in an Orion and you're good to go.
So, to Kevin's point, could you put a in amps cap on what this,
20 amps.
20?
20 amps. Victron makes, what's the name of it? Orion 20.
You're talking about the rating of the DC to DC?
Correct.
Converter.
Correct.
That was something I'm not familiar with. I mistakenly,
Yeah. No, I'm glad you asked.
because
No.
I know like a 1G Myanmar comes with a 35 amp.
Yeah. Yeah, make sure you're not overloading. I don't know what the spec on that little guy is. Okay, I might not put a 20 amp DC, I might put a 10 amp on it, right? But this is for getting 20 amps or so to the house battery, 12 volt amps, right? 12 times 20 is 240 watts, so 200 watts to the battery, right? If you want to go up the food chain to something higher, turn it around. And this is probably this is a very common deployment we have with Wakespeed. You swap out the factory alternator with something more capable. And you connect this alternator to the house battery. You don't have the alternator charging the starter battery like this guy did. You have this alternator charging the house battery. And then you use one of those Orion 20 amp to convert from house battery voltage down to the starter battery. This works really good in the marine world. The starter battery requirements in the marine install is typically very, very modest. The chassis loads, as we call them. This does not work well in the RV world because the chassis loads in RVs these days are 20, 30, 40, 50, 60 amps. So now you're in that same space of buying a big alternator and a big DC-DC converter, and you're just like spending twice for the same amount, for the same thing. But for marine installs, this second approach is probably the single most common one we see in anything but very high-end systems, where you replace the engine alternator with a more capable alternator, you control it with a Wakespeed regulator to charge the house battery, and then use an Orion DC-DC converter to go back and charge the starter battery, okay? The next step up, and this is actually the one I prefer. This is what I've done on my personal vessel. You leave the factory system untouched. Factory alternator stays in place, factory starter battery stays in place, factory starter wiring stays in place, yet don't touch it. You then add a second alternator dedicated to the house with the appropriate regulator to make sure the house battery is being charged as it should be. I like this system for a couple of reasons. One, remember, we can't just step out of our vessels when things go sideways. I have a level of redundancy. These factory alternators, there are a bazillion of these things made. They are largely dead reliable. If you don't mess with them and you let them do what they were made to do, which is to charge a starter battery and carry chassis loads, you can't improve upon these things. It lets me have a totally separate DC system. My personal vessel, I use a 12 volt house battery bank. And what I did is, those battery AB switches they have? I turned it around and I connected one side to the starter battery, one side to the house battery, and the output goes to my nav panel. I have segregated DC subpanels. One panel is my nav, that's where my radio, radar, autopilot is. That's through that AB switch. My house subpanel is directly wired into the house battery. But by having that AB switch, it lets me run my nav electronics normally off the house battery. If something goes sideways with that, I can switch it over and run it off the starter system. and it'll be more than capable of doing it. And it also gives me a built-in jumper by putting it into the boat position. My personal preference is to do this in the marine world. The only time you wouldn't do it is if you don't have the room or the ability to add a secondary alternator. Is there any questions about these kind of 3 fundamental steps? Yes, ma'am.
Yeah, would you review just one more time what you were talking about when you say chassis load?
If you have a in the marine world, most marine engines, all they do with the chassis load is they're running the instrument and gauges on the engine. If they have an electronic controlled engine, then it's running that. That's why the chassis loads on the marine system are very modest, maybe 5 amps, right? On a car, you've got all that, plus you've got the lights and the radios and the power steering and the fans and everything else. Now, on our boats, we usually move those things over to the house. You can't do that on an RV. Okay. Another thing you can't do on an RV, increasingly, is replace the stock alternator. Today, car systems, the stock alternator is highly integrated with the engine ECU. It's part of the emissions, it's part of the mileage. You can't change it. You can't touch it. Some places you can't touch it because if you do, the check engine light will come on. Some places you can't touch it because if you do, people with blue lights are going to show up and also ask if you ripped that tag off of your mattress. It's illegal to mess with them, right? So there's a difference in the RV world. This kind of single-walled approach, higher capacity, will not work in the RV world for those reasons. Yes, sir?
Sort of along those lines, do you find that adding a second alternator or swapping alternators ever voids like warranties?
That is a really marvelous question, and the answer is it depends. Unfortunately, engine manufacturers, their whole goal with warranties is to never pay money. So if they can find reasons not to pay money. You know, in addition, kind of related to that question, is not just the alternator, but the mounting brackets and the belt kits. That's as hard of a problem for adding a secondary alternator as anything. I would suggest that particular question, if you have a concern, take it up with who you're buying the alternator from. So again, we saw a lot of, we recommend a lot of Balmars because they've got good products for the spinning rust and they've got a lot of the mounting brackets solved for the marine engines. If it's the RV world, we have 2 large partners, American Power Systems and Nations Alternator. Those guys have got the brackets and the kits, and you can ask them about it. The answer is, anytime you're calling somebody to write a check, they're going to try to find reasons not to. So, and you will get asked that question by some customers. I don't have a stock answer. I don't have a hard answer for you. It's just the reality of the world we live in. Good question, by the way. Thank you. All right. As we start eating up the food chain to get more generating capacity, one thing I haven't talked about is I said that I consider high energy systems anything with a 3 or 4 kilowatt head or better. In the 12 volt world, a 250 amp alternator is a pretty big alternator. And realistically delivering 200 to 225 amps, that's a lot. That's at 3 kilowatts. And that's kind of the realistic upper side for 12 volt world. I usually say 2 kilowatts is the 12 volt world. 4 kilowatts, you double the voltage at the same amperage, you're going to get twice the power out of it. So 4 kilowatts is kind of an realistic upper limit for 24 volts. By the way, that alternator that I talked about with the 1 3/4 inch shaft, I think that was a 20 kilowatt 12 volt alternator. It's a ferry boat up in BC. So yeah, there are exceptions, but in the real world, you're largely limited to around 150 to 200 amps out of an alternator. And then the wattage is dependent on the voltage, because watts equals volts times amps. So as you double the voltage, you can double the wattage. So 12 volts is 2 kilowatts, 24/4 is 4 kW and the 48 volt is 8 kW. Those are realistically easily achievable outputs from a given alternator head. Yes?
So I don't know if this is getting off the Wakespeed topic, but how are you supposed to size? What's the proper sizing? How do you size an alternator?
Perfect. No, it's a great question. No, this is exactly why we're here, and this is why you get to hear me ramble on for 2 days versus 2 hours, right? So remember early on I talked about high energy systems. You're going to size your inverters based off the peak load. You're going to size your batteries based off how long that customer wants to sit and not have to use potatoes and listen to a generator. And then you're going to size your alternator head off of how quickly you want to recharge it. Our 48 volt installs that we do a ton of, they are able to start those Sprinter vans in the morning and do a fast idle for 20 minutes and they'll fully recharge the entire day's use on that battery. They've got an 8-9 kW head. If your customer needs to get that battery charged quick and that's what they want to do, you want more generating capacity. Okay? Now, another kind of secondary aspect that goes into that is what kind of ongoing loads are there while operating. Is specifically air conditioners. Air conditioners is the number one, the HVAC, electrically driven, takes a ton of wattage. So that will also determine how the minimum size of alternator head you want. So for example, coming back to these Sprinter vans, right? If they're running an air conditioner and it's pulling 3 or 4 kW through the air conditioner and you got an 8 kW head, you only got 4 kW into your battery, it's going to double the time it takes to recharge that battery. So that's kind of the math you want to do. Here's the thing to think about, the 3 major components, right? You've got your loads, the inverters have to be sized to service those loads. You've got your gas tank, that's the battery. That's how long you'll be able to service those loads until you have to start putting more gas into it. And then you've got your alternators. That's going to tell you how quickly you can refill that gas tank with the little sub point that some of that is going to get to diverted to ongoing loads. Does that answer your question?
Yeah.
Perfect. Yes, sir.
Okay. To that point, and while we're still in dual alternator world,
Yeah.
when we add a second alternator, the assumption is it will be correct brackets, correct belt and pulley ratio, correct alignment of
Yep.
things. Everything's done to I standards. Could you speak a little bit about how not to fall into the hole of taking all the data into consideration, the use pattern, the loads, everything, and now you've arrived at a second alternator optimal output. Now let's look at the driver and say, well, I've got a 35 horse Yanmar
Yeah.
with this boat,
Yep.
and I'm going to do a Balmar alternator, I'm going to do a Wakespeed regulator, I'm going to do their belt and pulley kit, all the ratios are already figured out for me, it's great, they did the hard work. Speak a little bit about what the upper limit of the load, the additional load on the engine and the fuel economy and the horsepower it consumes to add that second alternator.
Yeah. So there are, as in many cases, not a single answer to any question. In this particular case, because we're talking about large capacity alternators, 3 kW and above. So I think if you do the math with efficiency, you'll draw 1 horsepower for every 400 watts of energy produced. So if you've got a 4 kW being produced, you're pulling 10 horsepower out of that engine. That could be crippling. Wakespeed has a solution for it. We're going to talk about that tomorrow. Okay? The other aspect is when you're trying to pull 10 horsepower up through that belt, is the belt up to it? Well, the old rule of thumb, right, with the V-belts is 1 V-belt was good for 100 amps, right? So that's 1,000 watts, right? So if you're doing 4,000 watts, guess what? You need 4 V-belts. Well, no one's using V-belts anymore. This particular guy has a V-belt on it because, to be honest, my primary test bench has a V-belt motor on it. But that's why everyone's going to the rib belts. And Rick, do you have any insight as to what to consider when picking rib belts in terms of their ability to hold power?
You know, I don't know that there's a lot of data out there in terms of what horsepower loads, you know, the serpentine belts are gonna address. But we, you know, just from life experience, a six groove serpentine, which, you know, typically Yanmar is going to have one installed, you know, from the factory, that they're very comfortable with about a 200 amp alternator.
Right.
You know,
I
I've
believe
heard.
the biggest, the widest, like, I have a Dodge Ram.
Yeah.
The Cummins 5.9. It's 310 horsepower, whatever. And it's not tweaked or anything, just factory. I replaced the alternator, and it had an 8 groove. So about 1.5 inch wide belt.
Yeah.
Belt.
Most of the accessory brackets that are out there, the bell, whether they're Belmar brackets or you know, Grasser or whatever, most of those are coming with either an 8 groove or a 10 groove SERP, which, you know, I would feel pretty comfortable putting one of the 300 amp, like an APS or a Nations alternator. I think that would be, you know, more than satisfactory.
And I'll just share.
Yeah, go ahead.
Experience. I installed my first Belmar conversion belt and pulley kit.
Yes.
On a small Yanmar, I think it was a 20 horse. Anyway, I did it had the stock Hitachi 35 amp alternator, but I put that kit on there because it was experiencing chronic belt wear, not just from misalignment, but rust and, you know, abrasion.
Sure.
So I said, hey, you know, for a few $100 we can do this and you can forget about belt maintenance almost entirely. And what I learned was that in the kit, even though it was specified for my application of the Yanmar from Belmar, the belt was too long for the swing of my own. I couldn't use the belt that came in the kit.
So it tripped the nap.
No, well, yes, but, and that's the relevant piece. All 6 groove belts, we'll say, are not created equal. And I actually had to get a hold of Belmar, and to their credit, they sent me the right belt, and they credited me the one I sent back to them when they got it. But I couldn't just go to the auto parts store and get a belt that had the same groove profile, rib profile as the pulleys in the Belmar kit. So it was very specific to the pulley.
No, I understand that. In the V-belt world, we talk about A and B size belts. In the multi-rib, J and K are common ones. Some of the third-party kits, and I believe Belmar might be one of them, use a rib profile that's not commonly used in the automotive industry.
The J profile is an industrial profile.
Yeah.
The K is an automotive profile. So you have to go look in different places if you're trying to find an alternative source for the, you know, the Belmar belts. Typically you'd go to Granger or something like that.
Yeah. Well, I figured since they sold me a kit,
No,
it was presumed by application to fit my application that the belt.
You would hope, but
They were kind enough to say, okay, what length belt do you think you need?
yeah, no, and I think you really bring a good point. You know, we're spending a ton of time talking about the alternators and alternator characteristics. When we get into the world of the mount and the kits, it's just unbelievably complex. Belmar has a ton of history and experience in the marine world. Nations and APS have a ton of experience in the transportation world, the road world. When we get asked, because people will say, well, can I just go and buy this alternator? I'll say, well, yeah, you can, but how are you going to mount it? Right. They have no clue. So the kit is probably as difficult, if not more difficult of an issue. So those are kind of why we settle in on those 3 primary sources, right? The other thing that I'll comment on, you asked about how do you know if it's sufficient. I think our experience is the reason they've gone away from V-belts to the multi-rib. There's a lot of reason for it. One is they'll definitely do more power. We routinely see 8 kW heads, 9, 10 kW continuous duty with a multi-rib secondary alternator in the motor world. So those belts are definitely capable to it. If you have any questions, ask who you're buying these from. Yes, sir.
There's also another limitation, especially on smaller engines, that's the side load on the crankshaft.
Yeah, yep. Side load on the crankshaft, and not just actual side load. Do you know what we're talking about when we say that? Okay. You know, not just the actual side load, but the warranty. So some of these engine manufacturers get kind of pissy about doing side loads. We have had some people, they'll put, when they mount, yeah, we haven't even gotten to this bullet. Man, I'll tell you what, this is the best slide of the whole deck so far, right? When you mount dual alternators, you mount them on both sides of the engine so that you kind of equalize that side load. You don't have it. Some engine manufacturers will use it as a way, I think, I'm not going to say names. I have a name in my head, but I'm not sure if they're the right one. But some engine manufacturers will use it as a way to avoid warranty. I don't know if, do you know who we're talking about?
Volvo.
Yeah, that's what I was thinking of. So Volvo gets kind of annoyed. Mercedes-Benz, they say you can't put more than an 80 amp alternator on their engine for a variety of reasons. So every engine manufacturer talks about that, and it's all risk reduction. In the real world, if it's done correctly, it's not an issue. And if there is a concern, you know, use two. Or if you really have a massive concern, like this big giant alternator I keep coming back to, what they did is they actually had a jack shaft and a pillow block. So there was no side load at all on that. Multi-alternators, this is the next step up the curve. And this would be, for example, oh, I'm sorry, yes.
So if the limiting factor is current on an alternator, can you just increase voltage and then use something like an Orion to step down?
Well, you can, but why? Why not?
If they're saying like you can have a max, you know, if Mercedes says you can have a max 80 amp.
Oh, I'm sorry. They say 80 amps at 12 volts.
Oh, I see. Okay.
Yeah, they're onto that. Yeah. Yeah. Yeah, they're clever people. They're going to say, oh, no, you may. that's not allowable.
You can't like put a 48 volts.
No. I bring that up because you guys are going to have to design these systems. And you're going to get customers asking these questions. And the reality is there's no answer. You cannot install a high energy system on a Mercedes-Benz and meet the requirements. You just can't. The other reality is we have tens of thousands of them out there running with 6 to 8 kilowatt heads. And the side load or the engine load is not the issue. There are other aspects, there are issues that, you know, we can cover a bit. But it's just, you know, companies want to reduce risk, and if you've ever had a kid, you know the easiest thing to do is say no. Because they don't have to think about anything. No, don't have to think anything. Walk off. It's like, well, great, that was nice. Right? So that's just the reality. Yeah. But no, don't go down and overcomplex your design by trying to get around something like that. You know, think of a different way to have a high quality install without adding extra components and extra cost and extra failure modes, right? Let me look real quick here. Let me go through this very next slide because I think this will go quick and then we can do our break. How's that sound? So, alternator purchasing considerations. I think we've actually talked about almost every one of these topics. Voltage amperage, mounting of the belts, the largest challenge, regulation, internal versus external. My opinion, the starter battery, don't mess with the internal regulator because they're the best in the world. If you're doing a house battery, internal regulators are the absolute wrong choice. You need an external regulator. There's something called P versus N. Do you guys know what that is? It's how you excite the alternator. When you have a field wire, if you apply a positive voltage to the field wire, that'll excite the alternator. That's the gas pedal. With an N-type alternator, which we don't see much here in the US, master volt or N-type, some European or N-type, when you ground that field wire, that's how you excite the alternator. Inside there, what they actually physically do on the P-type is one end's connected to the ground and you apply positive voltage here. With an N-type, they put one end tied to the power output on the alternator and you end up grounding this. That's the difference. Sometimes it's called A and B. You'll see those nomenclatures as well. You're going to get these slides, so you'll be able to go back and refer to these at some point. We've talked about be wary of data sheets and marketing. My partner calls it more hat than saddle. Beware of that. Also, we have had horrid experience, with very few exceptions, of taking a stock factory alternator that was designed to do a starter battery loads and converting it for house battery. Rick has actually one alternator that he likes. And which one is that you say is actually pretty good? Is it the Vallejo or?
Yeah, the Vallejo that comes
Vallejo.
standard on most of the Yanmars these days. It's actually very easy to modify. Balmar actually makes a kit where you can just yank. It comes with the regulator and brush holder are all one module. It pops out, you pop in a new one, it's 3 screws and you're ready to go. It's pretty cool. And it's a good robust alternator. Yeah, that 120, 125 amp Vallejo alternators. A good alternator, particularly if you're kind of in that 400 to 600 amp hour range.
Yeah, so that's probably the sole exception that we're aware of that's been pretty successful converting stock alternators to external use. We have people who will take old school alternators, they'll take them to an alternator shop, 90% of which don't know what they're doing unless they got somebody who looks like me in the back room. Just be really, really wary of any alternator converted stuff. Okay. The last thing to talk about, and we've already covered this here, is sizing your system. We talked about how to size your inverters, your batteries, your alternators. We talked about the trade-off of the voltages. Remember your wire sizes as well. You want to keep those all in line, and those are all amperage based. So one of the cool things about going up the higher system voltage is the wire sizes can go down because you carry the same amount of power with a smaller wire. You might want to know why 48 volts gets talked about. There is actually legal definitions for ultra low voltage. And it's 60 volts in the US and 75 volts in the EU. These are written into laws. When Rick and I, as Thomason Jones, got our business liability insurance, we were only covered with ultra low voltage. It is a legal definition, and if you go above that, you have additional requirements, you have additional liabilities. In the automotive world, 400 volts, actually 800 volts is most common these days. Anytime you're looking at a car and see something orange, just back away and leave it alone. But that's why you're seeing these high energy systems go to 48 volts. And that's probably why they'll stay there, because to be frank, the volume is rather modest compared to the rest of the world. We can accomplish what we need with 48 volts and don't need to go. All right, that's all I have on this. We'll take our break and then talk about batteries. All right, batteries, the fuel tank. I mean, this is where you store, this is where all the electrons gather until they get used, right? Typical high energy system will have a large battery bank. And the reason for it is that customer value of, I don't want to listen to a generator in the evening when I'm drinking my sundowner. I don't want to listen to a generator in the morning when I'm trying to make my coffee. Me personally, I didn't want to listen to a generator for 4 days. Our cruising style was we'd go and drop anchor for 3 to 4 days. We never knew when we'd leave, but that's typically what we did. We'd pull up anchor and we'd move away. Now, unfortunately, the deficiency with a 12-volt system, we talked about this a little bit earlier, is I could be at anchor for 4 days and not run the generator, but I had to run the bloody engine for 8 hours to charge those batteries because I had the 12-volt system. Well, if I had a 48-volt system, I'd only have to run it for an hour. My batteries would be fully charged every time we moved. So there's real-life examples where we got to. So the batteries, you're sizing them based on how long people want to be able to run without a charging source providing recharging. And that can be the engine, which we're really focusing on here, increasingly solar panels. Solar panels are really, I got another slide on this, they're really relevant in the marine world. We actually have 480 watts on Viking Star, and we'll talk more about that in a bit. Largely, the battery banks these days are lithium ion, and there's a lot of good reasons for using lithium ion. They have reached the crossover point in terms of costs. They have benefits in terms of density. They have benefits in terms of performance. Their charge efficiency is higher. You want to talk about energy usage? Lead acid batteries are typically in the 80%, 85% charge efficiency. Lithium ion batteries are usually 97% charge efficient. So there's another thing you can pitch to your customer. If you have somebody that's using their boat, if they're always tied to the dock, it kind of doesn't matter, does it? But they are very big investment, and you want to make sure you take care of them. And this is where people have migrated toward the Wakespeed when it comes to alternator charge systems, because we have enough control points that we can know what's going on with the battery can tell us what it wants, and we'll take care of it appropriately. Lead acid batteries, the great thing about lead acid batteries is a very mature technology. Been around for 100 years. They're relatively low cost. People know how they behave. They know what to expect out of them. Although there is folklore out there. One of the biggest reasons this whole Wakespeed exists is because of that nonsense that a lead acid battery is only good for 2 or 3 years. If you're only getting 2 or 3 years out of your lead acid battery, you've got a crappy charge system. We got 7 years out of our batteries before it was destroyed by, not one of these, but was destroyed by a shore power charging system. When we were underway and away from the dock, I'd pick up 5 to 10% capacity back in my lead acid batteries because we charged it properly. So lead acid batteries, they got a lot going for them, but they're 100-year-old technology, and we're at a point now where lithium-style chemistries really have a number of advantages, and they've arrived. It's no longer this mysterious thing on the forefront. So, in my opinion, there really is very little reason to go for lead acid in a high-energy system. The only single exception might be if you have an environment where the batteries themselves have to charge at low temperature. One of the limits of lithium ion is you can't charge them below freezing. Now, you can put heaters on them. In the real world, our batteries live in the lazarette. It's usually above freezing. In the real world, the batteries live in the coach, the cabin space, so it's above freezing. But I will tell you, one of the first service calls we started getting was, what's wrong with this Wakespeed regulator? It's not charging my batteries. And it's like, where are you calling from? New England. What's the temperature outside? Well, it's like -20. I have an answer. The Wakespeed has just prevented you from damaging your batteries. We realized it was too cold. We knew that the batteries weren't spec'd to charge at that, so we didn't charge them. Warm up your van and voila, things start charging. Okay. The other typical aspects, disadvantage with lead acid technology, and you all know this, rule of thumb is you only use 50% of the capacity. There are exceptions. The AGMs are bare. That Lifeline battery technology that I talked about, I'm sorry, not Lifeline, the Firefly battery technology I talked about, that was one of its values. And it actually worked well. It's unfortunate the company who delivered it, the actual battery didn't quite deliver what was capable from the technology. But typically lead acid batteries, you all know, 50% state of charge, that's the rule of thumb. That there alone gets you over the hurdle of why lithium-ion batteries today are more cost-effective, just because you only need half the amp hours to deliver the same amount of value. Now, because they're smaller and lighter, typically people will go upside if they can't afford to do it. The other thing, I want to point out this very last thing. That right there is the reason the Wakespeed 500 exists. And I'll come back to that in a minute. All right, when we talk about lithium batteries, lithium is just one part of the battery solution. There are other lithium-based chemistries. The ones that we talk about are LiFePO, lithium iron phosphate. LFP is what people tend to refer to it. LFP has a really good charging ability. It has a really good safety ability in the sense that it's one of the, going to the elephant in the room, the thing you hear about with lithium batteries, they catch fire, right? The thing that catches fire is largely the electrolyte inside the battery. Lithium iron phosphate, that chemistry, that combustion point, I think is like 430 degrees C, something like that. So it's a very high temperature. So typically lithium iron phosphates won't be the primary source of combustion. However, if something else starts fire and they raise that battery to over 1,000 degrees Fahrenheit, it will definitely contribute to it. The downside with lithium iron phosphate is their energy density is lower. It's about 30% bigger in order to get a certain amount of storage capacity. You will never find lithium iron phosphate in your cell phone. You will find other chemistries. You largely won't find lithium iron phosphate in electric vehicles because capacity is more important than some of these other characteristics. The downside to those is most of these chemistries have a combustion around 150, 200 degrees C. That's why your cell phone catches fire. That's why your hoverboard catches fire. I am belaboring this point because not only do customers not understand this difference, I will guarantee you when I stand on a number of industry standard committees, the industry by and large doesn't understand it, or there's self-driving motivators to try to make that confusion. When you hear about lithium batteries and you hear about the different, the downsides of the lithium batteries, specifically the F word, little side note, in the RV industry, we never use the word fire. It is a 4-letter word. We refer to that a thermal event has occurred. Now, I'm aware of some thermal events that ended up with a couple of frame rails and 2 round axles at each end, but nonetheless, it's a thermal event. It's never used the word fire. I am belaboring this because there is a ton of confusion in the consumer's mind about the dangers associated with lithium batteries. And yes, you have to be very careful with the ones used in here, with chemistries, the NMCs, the ones that have cobalt, the ones that have the benefit of higher energy density. But the trade-off is they're not quite as safe. And if you are using a battery pack with one of those things, you have to take extra precautions. For example, never mount them in the living compartment. There are RV, and that's not a bad chemistry. I don't want you to walk away with that. It's not a bad chemistry, it's just a trade-off. And if that's something you value, that higher energy density, you have to take the steps necessary to have a safe system. Those type of batteries are mounted outside the vehicle in a metal box. Lithium iron phosphate does not have that disadvantage. You can put them in the coach and they can be in a plastic box. That's kind of the sum of the differences. So is there any confusion or questions on this topic? Because it is one that we as an industry are truly trying to educate the population about the differences. Because all they hear is lithium and they think about that scooter that caught fire. Yes, sir.
So lithium iron phosphate, you're saying it's 30% lower energy density than lithium ion?
Then like the batteries that go into here. I think 30%. I'm going off the top of my head. Yeah, it's lower energy density. So
how's that compared to like AGMs? So it's only like 20. I guess that would be 40%.
Well, AGMs are significantly lower energy density, right? And plus the usable energy density is even less, right? And the weight of the fundamental materials, lead versus lithium, is certainly different.
So when you, sorry.
Yeah.
When you refer to energy density, presumably you're talking amp hours per pound and physical dimensions?
Physical size in this case. Physical size. This phone would be twice as big if it was well, I need to talk to him. This phone would be twice as big if it was a lithium iron phosphate battery. So that's why they're not used. Or it would only run 2 hours if it was this big. It's a trade-off. Remember, I came out of the computer industry, and we manufactured laptops first with NiCad batteries and then with lithium, and we went through the chemistries. And it's kind of fun to me to watch other industry discover things about this. Like, we knew what caused batteries to catch fire. And that's why the BMSs were created primarily for the laptop computer industry. That's where that all came from. We knew that those chemistries were more dangerous. And we worked with regulatory agencies. There's specific regulations how you can mail those batteries. That all came about because of being careful with these type of systems and designs, right? So, in a nutshell, 2 walkaways. There are many different lithium battery chemistries. The biggest trade-off, the one we care about The one we care about is the lithium iron phosphate. They are very safe. The ones used in every other consumer product and almost all EVs are chemistry that requires additional precautions around. And they have additional safety concerns. It's not necessarily bad. I mean, this thing hasn't burned in my pocket yet, but I'll guarantee you there's a lot more thinking that went into this and considerations than yes, ma'am.
Did you say that battery management systems in general came out of laptops?
I would make that statement. I haven't validated, but I would say that's probably true because we were using, you know, it's probably not an accurate statement. They probably came before that. But in terms of battery pack and portable energy, we had cordless drills and stuff, but really the highest energy usage was laptop computers coming out of the 90s. And, you know, a lot of development and learnings in that area. Like, for example, I'll tell you a little sidelight story here. Have you ever heard the phrase that when you put batteries in storage, you should keep them around 40% state of charge? It's better on the battery, don't leave them fully charged. If you haven't heard that, go to the battery manufacturers, lithium battery manufacturers, and they'll tell you that. If you're not going to use your battery, keep it around 40%. If you leave it at 100%, it will degrade the battery quicker than if you store them at 40%. Now, I smiled at that because we in the computer industry learned that lesson in the 90s when we transitioned to lithium ion batteries. Because before with NiCads, you wanted your batteries always stored at 100% or the batteries would degrade. So that's what we did. And then we started getting warranty claims because these computers would come off the manufacturing line at 100% state of charge and they'd be stuck in the bloody supply chain for 6 or 8 months and finally get to the consumer and the battery had degraded. Well, people are smart but slow, engineers. We kind of figured out that the problem was that we were shipping these batteries out at 100% state of charge and they sat on the shelf in storage for 6 or 8 months and that was harmful to the battery. So what was our solution? Ship the battery at 40% state of charge. And that is why today, whenever you get a battery, don't care what it is, the first thing they tell you is fully charge your device before using. All right, belaboring this a whole lot. Again, the thing I want you to walk away, because you might run across this with your customer. Different lithium battery chemistries. There's nothing wrong with any of them. They have pluses and minuses, but depending on the one you pick, you have to have additional concerns. For our use, lithium iron phosphate is the most common and probably most beneficial battery chemistry to use. Okay. BMS, touched upon BS. So lead acid batteries are forgiving. You can overcharge a lead acid battery, well, within reason. You know, you can continue pouring energy into it even when it's fully charged. And by and large, the lead acid battery is not going to care. He's going to off gas, you know, he's going to boil off some water. That's largely what's going to happen. Lithium-based chemistries, these newer ones, if you do that, it will physically damage the cell inside. And I'm not a smart enough guy to know what it does. I know back in Reno, for the company we work for, they've got a building full of PhDs who are smart enough. And if I asked them that question, I'd be deer in the headlight after 30 minutes while they told me what happened. But bottom line is, with these newer chemistries, there are newer restrictions. You can't charge them below 0 degrees C, or they'll physically damaged. You can't continue to charge them once they're full, or they'll be physically damaged. There's a lot of stuff. There are ways that the things will catch on fire if you keep doing stuff that you shouldn't be doing, right? So as a result, BMSs are present in any battery you want, lithium-based battery you want to be using. I was almost going to use the word always present, but never use absolutes, right? The BMS's job is to monitor that battery. The one job that BMS has is to monitor the battery for any overstressing condition. And if it finds an overstressing condition, it will disconnect the battery. That's its tool it can use in job number one. And it's called, it does a disconnect, and it's either internal. In this particular case, they're FET-based disconnects, which I think live I'm not sure where they live. They live somewhere in that cover. You might have other, like the Victron Lynx, you know, the Lynx BMS, it's got a physical contactor in it. There'll be a disconnect somewhere that if the BMS detects a hazardous condition, that you're either going to stress the battery to damage it or you're going to create a actual hazard, it'll pull the ripcord and it'll disconnect the battery. Yes, sir?
Is there any considerations for internal, like inside the battery BMS, for the ones that come with that?
Well, that's exactly what we're talking about. Yeah, the BMS, and I guess to your point, there are different ways to deploy this. You can have external BMSs, like the Lynx BMS. But actually, the Lynx BMS, you notice there's a cable that runs to the battery. There's actually, inside the battery itself, another little subsystem BMS. There's actually multiple components that gets distributed. The things that the BMS, whether it's all inside the battery or if it's distributed, that it's monitoring each individual cell's voltage, current, and temperature. And it's looking for a cell to go sideways. It's looking for an individual cell to say he's fully charged and we need to stop. It does on discharge size as well. It's looking for an individual cell to say I'm over discharged and we need to stop for either to protect the battery or protect the safety issue. That's every BMS in the world does that. And that's a massive differentiator between lead acid batteries and these lithium batteries. It introduces complexity. It introduces things you have to worry about. We will talk about load dumps in a bit and down the road. That disconnect can be a catastrophic event on a vessel if it occurs in an uncontrolled way. So a second thing a BMS can do is some of them have the ability to communicate out. They can say, stop doing that. Or they can say, well, keep doing it, but only do it this much. Different levels of communication in and out, and we'll cover the variances when we talk about legacy connections with a Wakespeed, or what I call a wiggle wire, where you have a charge enable, or if you have a CAN bus communication with the BMS. Each of those provide better ability for the charging subsystems and the battery to communicate and provide the safe values that we're looking for. Have you guys ever heard anything about BMSs before other than the phrase BMS? Not a little, okay. Have I explained well what it does? I mean, just in a summary, it's a little computer. And it's monitoring temperature and voltage of each cell, and it's monitoring the current, and the thing it can do is open the charge bus and discharge bus.
So, my question was more, these internal BMSs, if you have a whole bank, several batteries, and
Yeah.
each one has its own internal BMS, how would they work then with an external BMS if they needed one, or would those internal ones for each cell be monitoring them as a whole bank, or each battery, or?
Right. Every battery manufacturer is going to take a different approach. And I don't know if you all heard the question. The question was, how do these BMSs, because you got some that are all internal, and you've got some that are internal, you've got some that are all external, and you've got some that are a little hybrid, can you mix and match all this stuff? The bottom line is, as a designer, I will sit down and look at where the requirements are for our product and the values we want to deliver and decide how to split these functions. So in the case of, let's take an example of a lithium-ion battery. There are two variances you can get with lithium-ion. You get an external BMS, and that external BMS has got a communication port that goes to every battery. And every battery inside has got a little computer that's monitoring the cells and communicates out the status through that communication back to the master BMS. And that master BMS chooses what to do. The Victron Lynx is the same architecture. There's the external BMS, but it's really more of a collector of information, because inside each individual battery is a little BMS that's monitoring. It's less of a BMS, more of a sensor. It's saying what's going on and typically sending the information up, and then the master BMS decides what to do. Now, again, with lithionics, they offer their integrated BMSs now. And the only thing on the top of it is a CAN port that we use. So it inside, I don't know the exact structure, but I think inside they've got one BMS with wires that go out and sense the voltages and stuff. They don't have it distributed. It's all on one circuit board. That type of architecture is how each battery manufacturer chooses to approach the problem. You cannot mix different brands. You have to get all because it's a design. You can't take a Ford and put a Chevy engine in it. I know you can, but right. You see what I'm saying? All right. Is there any other questions on the BMS? Because I was told to talk about this a bit, and I want to make sure that we've covered it enough that you guys...
For, say, the Lynx Victron
Yeah.
application that you were talking about, so is that only going to be compatible with Victron batteries?
Correct. Correct. Because it's a system, right? And it's the Victron system. Yes, sir.
I've got a system I'm working on currently. Consists of 12 volt house bank of 3 Dakota lithium 135 amp hour in parallel. 405 amp hour. And I've got the Victron servo and I've got the GX70.
Yeah.
We're not going to talk about alternators again. That's for another time. But my understanding is the way I'm going to be able to communicate with the internal BMS of the Dakota Lithiums is through the software and a laptop.
So we will cover this in more detail. The computer science term is called in-band communication, and it's used the voltage on the batteries. But we'll cover this in more detail. Okay. All right. I'll go ahead and move off of this then. The key takeaway is lithium chemistry is more, I don't want to say fragile, but it's less forgiving. And you have to make sure that it doesn't get abused, and they all come with a little computer inside that monitors the individual cells to make sure that we're not overstressing the individual cells. And that is going to be important when we come back to your question. All right, components, inverter charges. This is another part of high energy DC systems. Pretty intuitive. You got to size the inverters for your load that you're going to do. The chargers, if you're at shore power, if they do have an AC generator, that can certainly supplement the charging of your big battery bank. Oftentimes, we will see in these high energy systems multiple inverter chargers. Some brands, I gotta say, Victron overwhelmingly, I think. I'm looking for Rick, where he ended up at. I think Victron overwhelmingly is the brand of inverter chargers. Yeah, I mean, you know, they just make a great product, and you've got a room full of blue, so you guys know about all that stuff. There will be usually, on the more modest systems, like on mine, Viking Star, I actually have 2 inverter chargers, and I did that for 2 reasons. One, the first one I bought, the spec sheet said it could start my compressor, and guess what? It couldn't. So I went and bought a 3,000 watt variant, and it was able to. So that's one reason I ended up. The other is I'm away from the dock 8 months out of the year, and I don't like to call beaver planes to fix my problems. I'm a bit more independent. So I have a level of redundancy. If one goes sideways, I have another one, because I'm also not camping for the rest of my life, and we have a washer dryer, so that has to keep working. Often we'll find multiple Victron, inverters either stacked to get 220 or parallel. It depends on your inverter charger supplier. And there are other good inverter chargers out there. I think today they're pretty much all pure sine wave, and they're all pretty good. If you go back 20 years ago, there were pure sine waves that weren't very pure sine wave. We can have a conversation about how value engineered affected the ability of a pure sine wave inverter charger to run that washer dryer, if you want. All right, the one thing I will tell you about is that 48 volts. So one of the benefits of 48 volts, aside from a higher capacity alternator head, is smaller wire sizes, right? That's intuitive. It also means smaller inverters. when you design something, largely the limiting factor is the amount of current going through. That's the thing that tells me how many FETs I have to have, how much cooling I have to have, how big of a transformer I have to have. If I cut the current to a fourth, I cut the number of FETs and cooling and transformer. I mean, not really, but 48 volt inverters are typically smaller. They're often less expensive, and they're often more efficient. So that's another benefit of going to 48 volts. By and large, in the RV industry, we're seeing it be adopted fairly quickly. My belief is the marine industry is still a couple years away before you start seeing wide adoption. So you might start seeing some early adopters these days, but it'll probably be a few years away before they go to it. All right, solar panels. I want to talk about this a bit because even though I make an alternator controller, solar panels is a really, really viable technology these days to apply to boats. I mentioned that we have got on Viking Star 2, we got 480 watts worth of solar panels. I'm not one of those guys that's going to go out every day and 4 times a day and adjust the panels to point them to the sun. I'm not the guy that's going to worry about the optimal angle or the fact that I've got shadowing coming over from my derrick boom. I just don't worry about it. I got them mounted flat, and I got them up to a controller, and guess what? They provide probably 80% of our electrical usage from about May through July. Curiously enough, May is often my highest energy producing time. Can anybody guess why that might be? There's 2 reasons. Yes, ma'am.
They're cooler.
That is absolutely one. Did anybody hear what she said? They're cooler. Solar panels are more efficient when they're cooler. That's absolutely correct. What's the other one?
Same position of the sun in the northern hemisphere.
It's related to the sun, but it's not the position. In June, there tends to be more moisture in the atmosphere. So it gets, May, you get these, look how blue that sky is. You get these beautiful crisp days. Actually, curiously enough, during the summer months, we actually can generate more power here in the Pacific Northwest than Florida, largely because of the humidity in the air. And that's not just my opinion. The government has published studies and blah, 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 blah. You can go and look it up if you want to. So anyway, solar is wonderful. The one thing, and I don't know if you guys know this or not, but these energy tax credits for your houses to put solar panels on, guess what? If you have a bed and a head and a galley, you can apply those same tax credits to a vessel. Don't take tax advice from me, but go and research it. And it's not an extension, it's written into the tax credit laws. It says RVs, marine, secondary homes, your customers can get a significant amount of money back for everything needed to turn sunlight into hair dryers. Solar panels, charge controllers, batteries, inverters, wires, nuts, screws, bolts. The state of Washington, when I did mine, forgave all the sales tax. I'd take my little form to Ace Hardware because that's where I stored all my little components. I'd go to Ace Hardware and get that little nuts I needed. I'm not sure how much they like me, but I call myself aggressively frugal. My kids have other words that they would use, but if I could save $1.29 on sales tax, by God, I was going to make that paper there, right? So don't overlook this. Research it. I did mine several years ago. They changed slightly how much you can deduct and also make sure you meet the criteria. But don't overlook this, because this is going to be if you've got a 6-figure install and you throw a few solar panels up, that's some real money. What else? Classic things about solar panels, shading. That's the classic thing. There are 2 problems with solar panels on the boat. One of them is shading. The boat turns, the mast, the sailboat especially, or in my case with the trawler, the mast or an antenna, you get partial shading over the solar panels and you lose output. Consider using multiple micro charge controllers rather than one big giant one, because if you've got them all in series and this guy is restricting the output, it affects how the rest of them. Whereas if you use multiple independent ones, this guy can be running full out and this guy's maybe running 30%, down 30%. The second thing, the second thing that affects solar panels is seagulls. So people are going to have to go out and clean that glass once a week, because it turns out that wherever you have boats or you have boats at anchor, there tends to be a lot of birds flying around for some funny reason. There are other details that I'm not an expert on, but hopefully you will cover. There are requirements around grounding of the solar panels, and they're different in the marine world. So the physical, just like an inverter, you have to run a safety ground wire. Same with solar panels, you have to take that into consideration. So make sure you research and understand what that requirement is. And the last thing I will say is 48 volts is actually tough. Most solar controllers require that the input voltage on the solar panel is higher than the battery voltage. So that means if you're going to charge a 48 volt battery, which we'll get to 50, 55 volts, you have to have like 90 or 100 volts out of your solar panel. Remember that magic line I told you about, 70 volts? We just crossed it. So there's two difficulties of getting to those higher voltages. One is you have to connect multiple panels in series. So that comes back to the little microinverter stuff. And the other difficulty is you're at higher voltage and additional safety requirements. There is no easy answer to this today. So that's one of the unsolved aspects of 48 volt installs. And by the way, in the RV world as well, I mentioned I sit on a lot of standard committees. We're discussing this because we want to make sure that there are safety standards and best practices out there, and we haven't come to a conclusion yet. So that's just one last comment on 48 volt systems. Any questions on solar? Yes, sir.
On that specific
Yeah.
hurdle, is there a way to configure a solar array and one or more controllers and then go to a DC to DC converter?
There are a couple of solutions, and we're not focusing on these, but like one solution, I mentioned this product called the Wakespeed 3000. It is a bidirectional converter. So what we would do in this particular case is we'd have people connect their solar panels down to a 12 volt battery, and then we'd have that converter pull energy off the 12 volt and up to the 40 volt side. That's how we solve that particular issue. There are a very small number of, the requirement of having your panel voltage higher than your battery voltage has to do with how that converter is made. And it's called a buck converter. You are bucking a higher voltage down. 95% of all solar controllers out there are buck converters. There are a small number, and you can research them, but they're kind of in the weeds, a boost converter, where you can take a lower panel voltage in and supply a higher voltage out. There's even a less common buck boost. These are electrical design characteristics. When we design a switching mode power supply, which these all are, we either make a buck converter, we make a boost converter, or we make a buck boost. They are physically different. They're very related in how they work, but how the FETs and the components are placed. And if you make a buck boost, you double some of the components, so the cost goes higher. So the answer to your question is there are solutions out there, and but there's no ready way for me to say, look, here's how you solve it. I think it'll be solved in a few years, but not today. Okay. Any other questions on solar? All right. So I was asked to give a little color about Wakespeed and the Wakespeed story. So all of this is going to be kind of self-promoting in some ways, but it's going to give you a little history about how Wakespeed came about. Myself and Rick Jones, we formed Wakespeed Offshore in 2018. And there are a couple of beer stories, which are wonderful beer stories, about how Rick and I's path crossed. Rick, who chose not to join Balmar, had formed a company called Wakespeed with Michael Frost. Michael Frost is another person who is actually relevant here. He has unfortunately passed. He was the designer of the Balmar regulators. he is the guy who recognized the difference. And I'm sure there were a lot of people, but he was instrumental in delivering the products that recognized the difference between how you charge a starter battery and how you charge a house battery. And this is back in the 80s, Rick? Yeah. So when Baltimore was purchased by a holding company, Rick and Michael did not go with that purchase. Sometime later, they got together and said, hey, we're clever people. What can we do? And they decided to make a very simple alternator regulator for the wakeboard community. It was very narrow focused. It didn't have to charge the starter battery so much. It didn't have to charge the house battery so much. What it had to do was drive those giant speakers. So they sold, and correct me if I'm wrong with some of these details, Rick, but they offered a kit that was a replacement alternator and a very simple regulator that we actually sold as the Wakespeed 100 for a period of time, had 2 knobs on. What battery do you have, and how much do you want to derate your alternator? That was it. Very targeted focus. The sad part of the story is that Michael passed before they could complete that product. Some period of time came around, and that's one of the beer stories. Rick and I paths crossed. We formed Wakespeed Offshore in 2018. I finished that design of the Wakespeed 100. We productized it. There had been my cruise up the river where I figured out that the glossy magazine things didn't work. I had created something called the VSR, Very Smart Regulator, sometimes called the Arduino Alternator Regulator. It was an open source product because I retired and I didn't want to have a business. You know how that worked out. But that is where that technology came from. We formed Wakespeed Offshore. We commercialized that technology. That's what became the Wakespeed 500. We were widely accepted. I have said tens of thousands. I'm not going to tell you the absolute number, but I'll guarantee you we have sold tens of thousands of these products into various deployments, largely into the RV segment, and a significant portion of them in the 48 volts, followed by 24-volt installs. And almost a year ago, I think it's a year and like 4 days ago, we had been approached by Rick and I, and also you might hear this phrase, Thomason Jones Company. Wakespeed Offshore was a DBA. Wakespeed's a product brand. Thomason Jones Company, if you ever hear that, or TJC Micro, that was registered with the state of Washington, just to clarify any of that, if you care. We had been approached by a number of entities to procure the product. We had several people we were talking to. We had a number of hard offers on the table. We weighed the different choices. They were all very good offers. They were also, from a pure MBA standpoint, too early, because we probably should have been in business for another year to support our valuation. But these entities saw enough value in us that they made, they were willing to take a risk. And we chose to join Dragonfly Energy. That's who's here today. That's who Rick and I now work for. Dragonfly Energy, you might know, one of their brands is Battleborn. So they make the Battleborn branded battery. They are a lithium battery manufacturer. So now we've got Dragonfly Energy, which is the publicly traded company with the Dragonfly Energy, or the Dragonfly branded battery that largely goes to OEMs, the Battleborn battery, which is largely direct to consumer, and the Wakespeed Offshore brand, which is the Wakespeed Alternator Regulator. I'll just say from a personal standpoint, I'm very happy about this. It's been really great, the fact that we've got, award-winning filmographers recording this session here today, and they can produce material, for our products for us. I mean, this is a small company. We were literally at the point where we had to expand. We were looking at facilities in Anacortes. We were looking at hiring people. As a business, we are at that next step. So it was the right time for us, and we're very happy. I asked my wife what she wanted out of all this, and she said she just didn't want to have to push LEDs into the lid. So she got that. And here we are a year later, and we're very pleased. So that's kind of the business aspect background. Yes, ma'am.
As you now are associated with these other brands and designs, is there cross-compatibility between those different batteries?
Absolutely not. They're 100% different. I mean, it's the same answer to the question we had before. Different pointy-head peoples in Reno design things away than the pointy-head people in the Netherlands, than the pointy-head people in, in these other states with the different batteries. And I'm the pointy-head person that knows how to manage the spinning rust. So yeah, there's absolutely no compatibility. But I will tell you, one of the aspects that was important to Rick and I was don't break Wakespeed. We had been very widely adopted. We support a large number of batteries. There's a lot of work and effort that goes into that, and we'll cover this more down the road. So that's an aspect that was important to us as we chose which of the offers to do. Okay. All right. Wakespeed 500. So I've alluded to this a lot, and normally I wouldn't put this in, but Kevin said that you guys wanted to hear this, so it's in. My wife and I, we retired on a 1961 45-foot Monk McQueen wooden trawler, Monk Senior design. It was the home for Christy and I. We moved on full-time in 08. We started doing the refit on it sometime in 2000. This was by choice. I think I was telling some people, or I don't know if I told you, but when I had my summer job in high school, I worked for a contractor as a gopher laborer, and I watched him, small business down in Portland, he built tilt-up buildings and stuff, and I watched him get a big stack of money and retire at 70 and die 2 years later. And I thought that was nuts. So I set a goal to retire early. In my late 40s was the 08 downturn. The company I worked for sat me down and asked if I would consider leaving them, and they slid a piece of paper across in front of me, and I pulled the paper and I went, I think we can make that work. So we retired in 08. We quickly started liquidating everything we owed. We sold our house just as the housing market was crashing. Probably one of the luckiest moments in my life. The second luckiest moment in my life is I cashed out my pension and invested in the stock market within 3 days of it being at the lowest point. So we lived the life. I'd read all the glossy magazines because I wasn't going to go camping. We have heating, we have a water maker, we have a washer dryer. We've got everything that we would consider. We have modest requirements, a modest life, but we have everything that we consider for our comforts, along with a safe and reliable vessel. High degree of redundancy, fuel efficient, see where the hull of the vessel's actually design point is ocean crossing. I'd have to put the fact that it's 60 years old, we won't talk about, but the only thing you have to do to that vessel for an ocean crosser is storm plates and some sort of roll control. And it's actually, if you get the original version of Voyaging Iron Power, you'll find that design on, I think, 238. So very capable vessel, fully self-contained. We lived the life, and we lived this life for 10, 15 years, until I met Rick. Then we had a different life. So that's how this all came about. I think I mentioned before that our typical cruising style is we leave the dock now. We wander over in Friday Harbor. We'd leave the dock. We'd find an anchorage. When we saw people, we'd go more north. We came in once a month for heavy provisions. Usually about 3 weeks out, we'd go to one of the outlying stations, see if we could get a little limpy, celery or a mushy apple to have some sort of fresh. So that's what we lived. During our shakedown cruise, we cruised up the Columbia River, and Viking Star's actually been to Idaho. You can get into Idaho about 100 yards. There's a bridge, they ain't gonna open. You can get more up the Snake River out of, I think it's Clarkston, into what they have, the Blue Bridge. And it would open, and if it did open, you could go probably another half mile. But apparently, I mean, this was in the mid-2000s. Apparently, at one point, they had lifted that bridge, and when they tried to put it back down, it wouldn't go down again. So the city said, I don't care that this is navigable waterways, we ain't lifting the bridge. So there's a marina on the north side of that bridge. Their cruising ground is like 2 miles. That's all they can do unless they get a truck to get all those big boats out of there. So we've been up to Idaho. We've been as far as you can go up the Columbia River. No little interesting tidbit. when you get far enough up the Columbia River, you'll notice the official government charts change. The nav charts, all of a sudden, don't have depths on them. Happens to coincide with where the Hanford plant is. They have depths up to the most downriver corner of it because there's a big dock there. Everything above it, there's nothing there. Kind of funny. Talking to the locals, you could go another 3 or 4 miles upriver before it came free. You still had lake effect for another 3 or 4 miles, so you could go river, but we chose not to. So that's what we did. During that cruise, we were away 6 weeks away from the dock, is when I, as a retired EE and CE, figured out that that glossy magazine thing I had installed, sold to me by a really good marketing guy, didn't work. We probably had a slightly more demanding need. We had large batteries. We depended on those batteries. We were away from the docks for long periods of time, but it would chronically undercharge the batteries. It would enter float mode when the batteries were at about 85% state of charge. My solution during that shakedown cruise was to literally turn the engine off, then restart it. Because the glossy magazine regulator, I could configure a fixed time period where it would always be in bulk, and then it would make its decision and go in the float. So I could get about 30 minutes every time I did that. That didn't work. That wasn't going to happen. That is why this whole Wakespeed occurs, because from my standpoint, the regulator was guessing what the battery needs were, and it was guessing wrong. Here's the deal. Classic battery charge curve. You rise the voltage up. It'll come to a certain voltage point potential, and then you hold constant current, or sorry, constant voltage, and the current, the acceptance current of the battery drops. Doesn't matter the technology. I know early on, they say, well, these batteries need this, these batteries need that. In the end, all batteries run this way. If you go and talk to manufacturers, this is what battery manufacturers will document as their preferred charging methods. So the issue is that with this glossy magazine regulator terminating the charge, because it would terminate the charge like about here. While the battery was still drawing lots of energy in to try to recharge, this thing would terminate the charge. Remember I told you designers, we make choices and we choose one way or another? You can choose to, if you have limited information, you have to either overcharge or undercharge. I would choose to undercharge, because if you chronically undercharge batteries, it will cause irreversible damage, but that damage won't show up for 2 or 3 years. Remember, we're talking lead acid here. If you overcharge, and that's from Reliant Battery, their study. Manufacturer of lead acid battery, that's what they say. Don't charge our batteries, they will die early. If you overcharge a battery, it will die also. You'll significantly overcharge it, it will also die. That'll probably show up in 6 months. So if I'm going to choose one of the two evils, I'm going to choose this one. I'm going to undercharge. And then when customers call and complain, just say, your batteries are 3 years old. What more do you want? And that was a prevailing wisdom in the marine industry. Your batteries are 3 years old. I mean, the guys that have been around long enough, you've all heard that. Bull pucky. 3 years old, your batteries died because they're not being charged properly. And what was missing? We weren't listening to the batteries. The battery has to be held at a constant voltage, and this point here, the tail current, that is the trip point where the batteries will tell you that they are fully charged. Every battery chemistry is out there. I don't care if it's lead acid, I don't care if it's NiCad, I don't care if it's iron phosphate, I don't care if it's the old Edison iron batteries, it doesn't matter. They all work this way. You bring them up to your charge point, you hold that tail current, and when it reaches that threshold, you know that you have reached a fully charged battery. And that is the first and fundamental difference on the Wakespeed 500. We simply added monitoring of the battery current. We would monitor what the tail current is. We wouldn't guess. We wouldn't look at the field drive as a proxy because if you look at the field drive, you don't know if that energy is going to a hairdryer, to the battery, you just don't know. By monitoring the tail current, we knew what was going on with the battery. The battery would tell us what its needs is. And we could either continue charging and the battery's fully charged, or if we left the dock with a fully charged battery, we could realize it within a minute and stop charging and not damage the battery by overcharging. That's the first and foremost difference of the Wakespeed 500. And his hand was first.
So I'm seeing the tail current moment in time
Yeah.
as the transition between absorption and flow.
Correct.
Yeah.
And every battery manufacturer, that's their preferred. They'll have other approaches. If you have a voltage-only charge, they'll have ways that you charge it. If it's even more rare is a constant current charging source. You don't see those very often. But some, like Penn, they'll publish those type of curves. This is the preferred way. Every one tends to be 1 to 3% battery capacity is what we've seen. That's the trigger point. That's when you know the batteries are full.
So this is really brilliant because the battery is telling the charger what to do, not the other way.
Exactly, we listen to the battery. Go figure. The battery knows what it wants. Why don't you listen to it? It's like, how many of us are married? What's the smartest thing in the world you can do? Listen to your wife or guess at what she wants? We simply listen to the battery. Oh, you know, then you get guys like me on the Columbia going this, right? Yes, sir.
Could you describe trail current a little bit more?
Yeah, so tail current, there's different words that are used. Tail current is sometimes used, threshold current is used. What it means is that as the chemical reaction happens in the battery, as the battery is reaching its full state of charge, there's less opportunity to have that chemical reaction. The voltage is the push. That's what's forcing that reaction to happen. And if there's less opportunity for it to happen, you get this trailing current coming down. So well, it's a causal. I mean, we have the voltage providing the push. You know, we're saying, here's more food, eat it. And the battery's saying, nah, I'm kind of full. I don't want to eat this much. So as it gets fuller and fuller, and this is where you got to get the PhDs out of the room to talk about what's really happening at a chemistry level. But as the opportunity for a chemical reaction to happen diminish at a certain potential applied to the battery, the acceptance current will be lower. Acceptance current, you can call it. Some people call it tail current. The real key is this point right here. When you've reached that, and every battery manufacturer is different, when you've reached that 1 to 3% of battery capacity, which by the way is why the Wakespeed has to know how many amp hours of battery you have, so we can calculate that. That's when the batteries are telling you, I'm full.
And you're looking at that moment when the decrease in amount of charge drops off precipitously from the earlier decrease that it was already experiencing?
We don't look at change from yesterday. We look at moment in time because batteries age over time, right? So even if you've set something up, so there are other, and I'm trying to finish up here because it's time for a break, but I'll finish this particular topic. Even in, there are some products out there that actually do this, but they don't do it by measuring the alternator current. They do it by measuring the field drive, and it's a current proxy. Remember how I told you that alternator output is a function of how hard you drive the field, and its temperature and RPMs? Well, in a controlled environment, you can take all that information and you can know how many amps are coming out of the alternator. So there are some products out there that say, hey, we'll just look at field drive. Because all the time we're doing this, we're going from like 100% field drive here. And then now we're at like 90%, 80%, 70, 60, 50, 40, 30, 20% field drive. So we'll let the customer install a threshold that says, when you get the field drive, battery's full. It's an indirect way. It's a proxy. It works great in the lab. Doesn't work in the real world because batteries age. So that 10% or that 20% drive is good today, but 3 months from now may not be good. Temperatures are different. Somebody started a washer dryer. We would do this often with Viking Star. We'd come in for heavy provisions because I didn't like listening to water makers. So we'd do a load of laundry, start it up, we'd go get our groceries. But it takes hours to do that load of laundry and drying, and I didn't want to stay tied to the dock, so we'd do our laundry, top off the water tanks, and then we'd pull away from the dock. Well, guess what? We're also using the cheap electricity on shore to charge the battery. We pulled away from the dock with 100% charged batteries, drawing 150 amps out of the alternator. If you're doing a field proxy, because to get that 150 amps out of the alternator, we're probably 80% drive on that alternator. If you're doing a field proxy measurement, that alternator thinks you're way up here. It doesn't know that is going to the dryer instead of the battery. So it's going to keep charging the battery. Even though the battery's only taken a small percentage, guess what? You're overcharging your battery. You're damaging your battery, which is why a lot of these field, ones that try to infer what the battery is doing, they'll have a timeout. So it was really a very simple problem. All you got to do is listen to the battery. And that is the first and fundamental change that the Wakespeed technology offers. We fully instrument the battery and we listen to it. We let the battery tell us what to do. We don't tell the battery what it should get. So let's go ahead and take our break. And then next, we get to dive into the Wakespeed regulator itself, what it is, and how to set it up. I think what we're going to do is probably just kind of go over what the Wakespeed regulator is and maybe talk about some of the hardware choices you do when you're procuring it. And then after lunch break, we'll come back in and we'll talk about how you would actually deploy a Wakespeed, how you would actually wire it up. We were just having a sidebar conversation again about the BMSs and you know, the different ways that they are deployed. So I want to come back to this topic a bit. Bottom line, all BMSs, they will monitor the battery cells for hazardous or damaging conditions, and they will pull the ripcord. They all do that. And it doesn't matter if it's a BMS inside the battery or if it's a BMS outside the battery with some communication, or they've taken that BMS hardware and split it in half electrically and put some in the battery and some out. Doesn't matter. How the BMS is packaged, this is what I call a packaging issue when I'm designing it. Do I put all the functionality in this package, or do I put it all in this package, or do I split it up? Doesn't matter. The value and the function that the BMS does, all of them. If the cells are going sideways, we're going to pull the ripcord. Another function that the BMS often does is balancing. So you've heard that, you know, the cells, as they get charged, you have to do balancing a bit. So typically what we see is what's known as top balancing. When you get to this portion of the charge process, most BMSs will start, they'll trigger around 14.2 volts. Their terminal charge is usually 14.4. Once the battery gets above 14.2, the top balancers will be enabled. Every battery is a little different, but that's pretty common. And what that is every little cell is a little different. And you're going to have one cell that's an overachiever. It's going to be a little bit more charged than the rest of his guys. So the BMS will recognize that, and the most common way to do it is what they call bleed resistors. So they'll actually put a little resistor across that one cell, and they'll bleed energy off that cell, waste that energy as heat to let the other cells catch up. There are other technologies. There's active balancers where they'll take that energy and put it into a distributed system and shove it back in. REC, active BMS, is probably the most common one I'm aware of. But by and large, most batteries you're going to be exposed to use top balancing with bleed resistors. Another function that a BMS will often do is they will report out what's going on. So from a consumer level, they'll talk to the cell phone. And you can be nosy, and you can go in and you can see, what's this cell at, and what's that cell at, and what's the temperature at, and maybe it'll lie and tell you what the state of charge is. We'll get into the horrific quality of state of charge meters, even with lithium batteries, maybe a little bit later. But that's a consumer level thing, where the battery, you can often use a cell phone. Some of them will allow you to communicate with external devices. The Victron servo is a great example, and with the VRM. So you as an installer can monitor a boat worldwide, what's going on with that battery through the VRM. You can go in and see the cell levels, all that kind of stuff. That's another function that some BMSs will do, external consumer level communications. Some BMSs will provide an external, I'm getting pissed, stop doing what you're doing. I call it a wiggle wire, charge enable wire, charge disable wire. The battery's getting stressed, and before the BMS opens the contactor and opens the charge bus, it will signal out through this wiggle wire to stop doing what you're doing. Case in point, the Victron VE bus BMS. That's how that particular product works. Okay? That wiggle wire will go inactive, and the Wakespeed will turn off and stop providing charging, and then hopefully the condition will clear. And if it doesn't, if it continues on because you got some big giant solar panels that were misconfigured, at some point that BMS will pull the ripcord, but we're fortunate because we've already shut stuff down safely, and there's a really good reason for that. Another thing is that the BMS may have a richer way of communicating. And this is all relevant because when we talk about how to install the Wakespeed, we can support all these different levels, and how you wire it up is going to depend on your battery. This last level is where the BMS has the ability to communicate directly with the Wakespeed. We use the CAN bus. The BMS is able to send messages to the Wakespeed. It's able to send messages that says, stop doing this. It's able to send messages, I'd like you to do this. It's able to send messages that says, I'm doing top cell balancing. So instead of sending me 200 amps, send me 2. And the Wakespeed can take care of that. So the BMS, a very rich BMS, is able to not only protect your batteries, because they all do that, and communicate out what's going on, because many do that, and maybe also provide a brute force yes or no signal, because some do that. They can say, this is how much. Those are kind of the different levels that a BMS can do. Don't get wrapped around whether it's external or internal. And I've seen these in the forums. And I learned a long time ago not to participate in forums. It's just, there's no value in that. So that's, you'll never see me on a forum for a reason. It doesn't matter if it's an external BMS, if it's an internal BMS. That is a designer's packaging decision. I'm going to listen to my marketing group and the requirements on the product, and I'm going to decide how much of the electronics I'm going to put here and here. May put them all here, may put them all here, may divide them up. Irrelevant. The thing that's relevant is the function that is provided. Is it a very basic BMS where the only thing it does is protect the cells, or is it at the other extreme a very rich BMS where it has the ability to communicate out in real time, appropriate for process control, not just people being curious what's going on, but actually being an active part of the charging process. Does that help? Does that provide clarity on kind of this string of BMSs? And apparently not. All right, no, this is important. Let's go on.
What establishes that interface though? Is it all just like NEMA 2000, or does every manufacturer have their own, like, I don't know, API or something?
All of the above.
I see. So for you from Wakespeed's side, you have to go to every manufacturer and get, I guess, you know, their SDK or their docs.
Yep.
And implement that.
Yep. You will see when we talk tomorrow about how to configure the Wakespeed, you will see where you select the battery. And you select the battery by brand and communications. There's probably half a dozen common communication protocols. There's RVC, there's 1939, there's NEMA actually doesn't have sufficient capability to implement any of this, so we don't worry about it. There's SMA, there's Lux, there are proprietary protocols. It takes us anywhere from 1 to 3 man-months to work with a given battery manufacturer to support these protocols and proof that it's a safe system, which is why we have a fairly finite list. Because if it...
Sorry, so every time you do a firmware upgrade, you have to test against all of those?
Yeah.
So, okay.
Yeah. We have a regression testing that we do, and we do major and minor. Yeah, major firmware upgrades are, yeah, we use a whole process that comes from my experience in the carrier industry, and there are you know, alpha, beta, release candidates, there's regression tests. We have a whole list of stuff we do. But to answer your more direct question, there are a number of common standards, and we're going to talk about this with the CAN tomorrow, because CAN is the mechanism that we use to physically move information back and forth. Then the protocol on top of it is the detail you just asked about. And some of them are published, and some of them aren't. We have proprietary relationships that we can't talk about. So some battery manufacturers use open industry standards, and some choose to do it their own way.
Sorry, one more question.
That's these guys up here, right? Yes, sir.
Are they usually encrypted, or can you just reverse engineer them? Like I just.
Yeah, you can sniff them. Absolutely, if you want to.
I was thinking like, if you have like a Raspberry Pi or
Yeah.
something else, you can just pump it through.
You know, just issue a command $ESM:1 to the Wakespeed, and it turns it into a really expensive can sniffer. It'd be like hooking up your Raspberry Pi with a can hat and issuing the Linux command can dump. So yeah, you can sniff it if you want to. I mean, if you have no other purpose in life, like me, and I've done that before, by the way. We are actually reverse engineering the Victron CAN protocol before we established direct relationships with Victron. We were going down that path. Hadn't really made the decision we were going to productize it, but fortunately Victron saw value in us, and we now have a very detailed engineering level relationship with them. So they made changes on their side, and we made changes on ours, and there are some of those messages that are published, and there are some that aren't, that we're utilizing.
Yeah, I was thinking about it in terms of like vendor lock-in. Like, if you want to step out of the walled garden, can you do that?
Given enough time and money and effort, you can do almost anything, right? That's kind of the answer. All righty. So this is more going to be a preamble, and then we'll break for lunch, because I often got asked on my boat if I fished a lot, and I told them no. I was an eater. And there's fishing and eating and this thing in the middle that had to happen, and it just pissed me off when it didn't happen. So I'm an eater, so we'll break for lunch. Wakespeed regulator, a lot of this is kind of a summary overview for you. A lot of these questions we've already answered. The Wakespeed considers the battery, what's the temperature, voltage, and current, what are the needs and status of the battery. It considers the alternator, what is the temperature of the alternator, what is the RPMs. There are load management aspects. We'll touch on it in a bit. But for example, if you put a 5 kW head on a one lung, 4 horsepower Swedish auxiliary sailboat engine, do you have any idea what happens when they try to move it out of port? It doesn't work. So we have the ability to accommodate for that through white space is technology we use in engine loading. We also look at, that's actually a lead in for the motor, the load demand. That's exactly what I was talking about. There are other aspects that come into play. I will tell you, if you want to really differentiate yourself, this is an aspect that is not really used very much in the Wakespeed, and we'll cover this more tomorrow. We also consider the system, because we're monitoring the battery current. Remember that tail current that's coming in? Because I'm not guessing at it by looking at how hard I'm driving the alternator, not only am I guessing where the energy is going, but I also have no clue if the solar panels are putting in energy. So from the Wakespeed's perspective, because we're actually listening to the battery, that tail current could be coming from the alternator, could be coming from the solar panels. More relevant, batteries have a C rate limit. What's the maximum current you can pump into them when you're in bulk mode, when you're really, really trying to hammer energy into it? The Wakespeed is able to know what that limit is and how many amps are going into the battery. And especially with large solar panel installs, we have a number of conditions where the solar panels might be putting in 100, 150 amps, and we'll throttle back the Wakespeed and only put in maybe 75 amps so that we don't exceed the C rate on the battery. So that's the thing that the Wakespeed considers. What's going on with the battery, what's going on with the alternator, what's going on with the engine, and what's happening with the whole system. A lot of stuff that's being considered, and then we drive what to do based on the full sensing. We are multiple regulator, and more so it's not just make break. It's not a bang bang regulator. It's a PID. We anticipate. I think I mentioned earlier on that we had that one customer where the alternator was going like a rocket in this temperature rise. We would see that change. That's the D. Proportional integral differential. That's the D aspect. That D was too high, so we backed off on the alternator. We'll do the same thing with voltage. If we're rising up toward batteries, when they charge, lithium batteries especially, they have this curve that starts going like this. If we start seeing the rate of change going too high, even though we're not at a terminal voltage, we'll start backing off to prevent ourselves from overshooting. So it's a multi-regulator, intelligent regulation. We are flexible. That one product will support any system voltage from 12 to 48, 52 volts. It will do 12, 24, and 48 volt selections automatically, samples the battery voltage at startup, and decides what the multiplier to use is. But you can manually put something in. If you've got a 32 volt fishing vessel, is the perfect example. There's no regulator out there except these things that were made in the 60s for those guys. We did an install because the fishing vessel said, I'm tired of having to replace $4,000 worth of lead acid batteries every 2 years. They were being chronically, in that case, they were chronically overcharged, weren't they, Rick? Yeah. So there's an example. The same product can support all those things, one SKU. We can do N-type and P-type with different harnesses. We can communicate with the CAN, whether you're talking to a BMS or whether you're talking to the display monitor, it doesn't matter. There's a lot of stuff we can do. NEMA 2000 displays, RVC-based displays, the Victron servo, the VRM, a lot of information can go out. So there's a lot of stuff that's gone into this. This particular product, I haven't done this for a while, but I think there's close to 7 man-years, 8 man-years, easy of development into this thing. We've been doing this for a long time, and you get the benefit of it. All right. The Wakespeed 500 has a number of configuration options. That's one of its benefits. Its greatest weakness is that it has a number of configuration options. You know that saying, your greatest strength, your greatest weakness? This is it. So we will talk about ways to configure the regulator. There are simple ways to do it, just using dip switches. There's really appropriate ways to do it using the Wakespeed app, which I'll remind you if you haven't done it, make sure you download it on your cell phones. There's really hard and painful ways if you want to be a computer science nerd, called editing the ASCII files directly. So we'll cover all that stuff. There is a document, there are documents out on the website that can help you understand the different aspects of the Wakespeed. And we'll cover a few of those things after lunch here. But go and look at the Wakespeed website, go look on the product tab, and there's documents about installation guides, there's documents about the various batteries that we know we support, and there's some example of how to wire those things up. There is a really painful 100-page document called the Wakespeed Communication Configuration Guide that really goes into the guts. But if you really go and try to take advantage of all the aspects the Wakespeed can do, and I'll tell you very few people do, that's where all your answers are at. We call that the Bible. There's also a Learn tab, and it's got a lot of videos on it on how to use different aspects. One of your best friends is going to be something called the Wakespeed Buyer's Guide. So you go make sure you go and look at that, maybe over lunch if you want to take a peek at the Learn tab and see what kind of stuff you can find. So we will be done now, and what we're going to do for the rest of today is talk about how you would pick the hardware aspect of the Wakespeed, the different hardware options, and the different wiring approaches given largely these batteries that I just talked about with the BMSs. And then tomorrow, we're going to talk about how to do the greatest strength of the Wakespeed and do it in a way that's not going to end up with less hair when you're in. All righty, ladies and gentlemen, we are now going to enter the portion of this presentation, which is the real reason you came here. How the heck do you install one of these Wakespeed alternator regulators? And I know that's important, so yeah, let's go ahead and cover it. I talked before about web resources, and I want to come back and reinforce that. We've got a couple of small printouts, one of which is you'll never see on the web, so make sure you get a copy of that test point thing. But there's a ton of other resources on the web. And go to wakespeed.com, and you're going to look two places. You're going to look on the product page, where we've got the Wakespeed 500, and you'll notice on the right-hand side, it'll say support, and there's quite a bit of information in there. There's the basic installer's guide, there's a more advanced installer's guide, there's the 100-page Bible, if you truly want to hate life. There is also a series of pull-downs. So we'll cover this more tomorrow, but there are a couple of ways of approaching the Wakespeed regulator configuration. One is using a Windows computer to transfer the files, configuration files. That's what we have on the support tab. There's probably 15 or 20 different representative batteries where we have pre-engineered configuration files that you can download, edit with a text editor to make the changes. There's a little guide that tells you how about going and doing that. Again, we'll go into more detail tomorrow. But the nice thing about it is that guide for those batteries you draw them, a lot of them have got wiring diagrams. I want to make sure I'm not going to trip over this chair. So these wiring diagrams, like here's examples. So for various batteries, it shows at a high level, but at a good degree of detail, how you would install the Wakespeed regulator for that battery. So make sure you go and look on the website, go to the product page and the support tab. The other place I want you to go look at is on the Wakespeed website and go to the Learn tab. This beautiful little picture here. There are a number of videos that are growing that talk about how to use the Wakespeed application, how to decide what to put into your Wakespeed regulator. This material will end up on there at some point in time. There are a number of guides that you want to make sure you take advantage of. And speaking of which, your best friend is on that Learn tab, the Wakespeed Buyer's Guide. This will change over time as we improve it. One of the greatest strengths of the Wakespeed regulator is it has a lot of options and configuration. One of its greatest weaknesses has a lot of options and configurations. We're going to cover some of the hardware ones here. This buyer's guide will help you navigate that. I think it's about 20 some odd pages now. Gives an overview of the regulator, the different options you can purchase. It then goes into if you're installing a legacy battery where you're doing analog instrumentation, this is the type of stuff you need. If you're doing a CAN-connected BMS battery, this is the stuff you need. So that single document is your best friend. I've already mentioned the Wakespeed application, available for Android as well as iPhone. Much more detail tomorrow. The application lets you create customized configurations. It's the best way, in my opinion, to create configuration files for the Wakespeed regulator. That's all documented on that Learn page as well. Okay, let's dive into it. So, placement. We find more, traditionally, especially in boats, you would put the alternator regulator near the alternator because that's mostly what it talked to. Talk to the alternator, what's its temperature, what's its speed. You might have a voltage sense wire that goes back to the battery. More and more, and you can do that with the Wakespeed, but more and more we are finding that the Wakespeed gets put back by the battery because there's more interaction with these batteries. You want to know what its temperature, what its current is, what its state of charge. You want to know all that type of information. In the RV industry, by and large, the regulators are located next to the battery. In the marine world, that hasn't really happened yet. Most of the installs have them in the engine room. So just be aware that there are trade-offs one way or another, and you can decide how you want to approach depending on your particular install. There are, by the way, different harnesses that we'll cover that kind of lean themselves toward whether the regulator is at the battery or whether it's at the engine. All right? Alternators. I'm going to come back on this. We talked a lot about this morning. This is a summary. This is my personal opinion. Not everyone shares my opinion, but this is what I tell people. Clearly, it has to support external regulators. I would be wary of converted alternators. There are some alternators that you can get factory kits to convert. Those are fine. But if you pull an alternator off an engine and take it to your local alternator shop, we've had a lot of troubles with those, because either the alternator isn't up to the task, or the conversion wasn't done right, or X, Y, Z. So stay away from those. Avalanche diodes, you're going to hear me talk about that quite a lot later on when things go bump. Avalanche diodes are a way to suppress high energy events in case of an uncontrolled disconnect. It is the industry best practice. There are people who will say, well, we just do this, we do this, we do this. The automotive industry decided that was the best practice in the 60s. I believe that it's still the best practice. And we have horror stories of installs that weren't designed correctly. The system wasn't engineered correctly. The very worst case that I'm aware of, hour and a half out of port, refrigerator caught on fire, $20,000 worth of damage. Fortunately, they were in coastal waters, wasn't a big issue. This is not a joke. We'll go into it later. Avalanche diodes. Wakespeed alternator settings, just one thing to know. We can drive the alternator by default. If you choose to use like the dip switches, there are some defaults we do. These are the defaults you should be aware of. Some alternators, we talked about where the temperature sensor should go. If you're using an alternator that has a temperature sensor and you want to say an 85-degree set point, that's not our default. You'll want to go in and configure the regulator to override that. We default to 100-degree C. We also default to 100% drive. If you have a white box, there's a dip switch here. If you turn on dip switch 8, we'll drive it to 75% by default. All of these are changeable, but by default, that's what we do. And then also the field drive on 48 volts. If we sense a 48-volt alternator, 48-volt system, we will, by default, cap the field drive to 25%. And the reason why, most 48-volt alternators use 12-volt rotor. There are some who don't, but in general, almost all 48-volt alternators that we've dealt with use a 12-volt rotor. So if you take 25% of 48 volts, you'll end up with your 12 volts, okay? So the only reason I'm talking about this is if you choose to use the built-in defaults on the Wakespeed regulator, just be aware of that stuff. And if it matches well, great. And if it doesn't, then it doesn't. I want to talk real quick here. You'll notice I've got two examples of regulators up here. This we call, oh, I'm sorry, carry it. I'm sorry, yes. Questions?
Is the avalanche diodes, is that the same thing as the alternator saver?
Yeah, same idea. But it's a difference between a Ford Pinto and a Mack truck. Okay. And trust me, this is a hot button of mine, and we're going to go well into it tomorrow on things to go bump in the night. Yes, ma'am?
Will you one more time say what the dip 8 is?
Yeah, sure. So lead into that, we have two versions of the Wakespeed Alternator Regulator. We have a black box version, and we have what we call our white box. And if you order them, this is the WS500B, and this is the WS500W. The white box is primarily intended for it was originally intended for our retail customers. It's got dip switches in it that will allow you to make very simple configurations using just a lot of good defaults. It also has got these RJ45 jacks, because if you've got multi-alternator install, everywhere in the world has got Cat5 cables. So you can go out and secure those and just plug them in, and you're done with your CAN bus. We also have a black version that we call the OEM version. This was primarily designed for customers who are buying $200 to $500 a month. They don't need that flexibility of the dip switches because they configure these things all 100%. They take the CAN out through the harness. So when you purchase your regulator, you're going to find these two different variances. And today, there are reasons to pick this white box, specifically Victron, because there are some batteries that use the RJ45 for their CAN bus. So that's one reason you want to make sure you do this. So when we're talking between these two variances, you'll want to make sure you always start with what's your battery and your BMS. And that'll drive what the rest of the system is, including where you have a black or white. On the white box, because we have dip switches, dip switch number 8, they're numbered in here. The 8th one, if you configure this with a Wakespeed app, all the dip switches are overridden, they don't do anything. With the exception of number 8, it's still active. What number 8 does is it's kind of, you know, sometimes it's called a belt saver or something like that. If you turn dip switch 8 on, if you do this little slider and slide it up, you know, so it's on, what it'll do is it'll cap our drive. We won't drive that alternator more than 75%. I will often suggest people when they do an install, if they have a white box, start with dip switch 8 on. Try it out, walk before you run. Is the system stable? Is the alternator, you know, not overheating? It's a good way to just kind of proof your system out. If it all seems working well, then you can turn dip switch 8 off. Some of our marine installers, this is another thing for you to consider, and when you learn about what these different parameters are, you may set up your system so that it behaves really well with dip switch 8 off. You may have decided that this system is stable if we cap the drive at 80%. So what I've had some marine installers do is they'll say, fine, normal is 80%. If you flip dip switch 8 on, we'll cap it at 50% or 60%. And what that is used for is if the customer gets out in the field and you get that phone call that says, my alternator is overheating, what do I do because I'm in Mexico now and it's just hot out? You can just tell them, well, take the cover off and flip on dip switch 8. That's just a little option. Okay, does that answer the questions we have? Okay, great. Oh, you know what? I'm actually going to go back one more because I don't have a slide on this. There's another thing that's different about these if you come up and look at them. You'll notice this is what we call a Gen 1 or a version 1, Wakespeed 500. This is a version 2. And the way you can tell is the USB. The regulators are largely the same. The difference between this design and this design was based on feedback. One of the feedback that we got from the field, because they love this little micro USB connector, because everyone has a micro USB cable, at least they did back in the day, they were twisting this thing off. It was too fragile. So, based on field feedback, we went to this more robust connector. That's how you can easily tell whether you have a Gen 1 or a Gen 2. There are some other changes made to this, mostly around manufacturability. Our circuit assembly house had some input they wanted to see. We did make some changes. This particular regulator we found, there are not everyone reads the manuals. Not everyone installs ways in a very professional way. There are limits to how much offset you can have on the grounds. There are 2 ground wires, one for the power side, one for the logic side. This regulator, we spec it at plus or minus 1 volt. It's actually 17 volts. If you exceed that, you'll create damage. We had one vendor that was returning, early on, they were returning these Gen 1 regulators, 48 volt installed, because they were burning up the regulators. You know, we'd get like one a month, and it's just like, what's going on? What we found out is that for the ground wire, because it went in a Sprinter van under the driver's seat, they just took that ground wire and they blew a sheet metal screw through the floor pan. That was their grounding point for the heavy current path on the Wakespeed regulator. So you got that voltage offset. So it's hard to say that was a design defect because, you know, if you're going to hook your ground screw to a sheet metal screw that you blow through the floor pan, come on, what do you expect? But the version 2, we did make a little more robust, these kind of real world, not following good practices type things. These version 2s with the larger USB have been shipping for like 3 years now. You may run across old stock with that small guy. Functionality, they're the same, though, just so you know. Yes, ma'am?
To be clear, the version 2 is both for the black and the white? You just have to
Correct.
have one of each.
Correct. Yes, they were both offered in black and white. When I pulled them out of the box, that happened to be what it was. And also, these happen to have the highly coveted and legacy graphics art lids on them. So nowadays they have a new refined branding. So yes, sir.
So is there a version 3 or a Wakespeed 600 in the pipeline, or are we safe by buying the 500?
So we are not allowed to talk about future products. I will tell you, though, that we are constantly looking at how to improve our products. This design has been incredibly stable, except for what I just described to you. This design is 7 years old from a hardware design. We've made firmware changes, and we are continuing to work on stuff, but beyond that, I'm not allowed to, I can hear the attorney right here going, say nothing. So, does that answer your question? Okay. All right, a wiring overview. So this is an example of our wiring harnesses. So we need to consider how we're going to attach to the battery, how we're going to attach to the alternator, and what kind of communications we're going to do. And this particular drawing kind of gives a summary of it all. This is actually out of our user's guide, I believe. And you can see this harness, which is actually this harness that I've not opened yet. And hopefully I won't create a problem. You can see this harness has got, this particular harness has got 4 legs. This is what we call our P can harness. We also make just a P harness that only has 3 legs. The extra leg that's on here is the can leg. So depending on your battery or your install, you can choose, you don't have to hook all the wires up. If you don't use them, just coil them up. But if you're going to use, depending on your battery and BMS you're installing to, this may be the way you want to attach to it. Or if you're attaching to a battery that's going to connect this way, and we're going to go in detail tomorrow, you can get away with this particular harness. So just so you know, there's these different options. So what we have in the harnesses, and I'm going to go into details more on each of these, is we have one leg that goes up toward the instrument panel. It has your power, your ignition, your idiot light. It has a feature-in wire if you want the regulator to behave in different modes. And that feature-in wire can be selected, like for example on lead-acid batteries, we use the feature-in wire as a way to select the equalize phase. On a lot of lithium installs, you'll connect your charge allowed or charge not allowed to the feature-in wire, and that's how the BMS can use its wheel wire, this charge enable wire, to communicate. The next leg that we're going to talk about is the one that goes to the alternator. So the alternator has got a red and black wire. This is the heavy current. This is the power side. Wakespeed regulator actually, if you think about it, it's got 2 sides to it. It's got a power side over here that powers the alternator. And it's got a logic side over here that's the smarts, the little computer portion of it. So this red and black wire goes to the power side. It supplies the power that then gets controlled out on the field wire. So the Wakespeed regulator decides how much of this is going to end up here. And that's the gas pedal, if you will, the field control on the alternator. That's how we manage the alternator. In addition, we have an optional stator sense wire. There are certain features of the Wakespeed that are dependent upon RPMs, and you can get RPMs in a number of ways. One way is through the stator sense wire. So that's what this wire would be used for. And then finally, we have a temperature sensor. The harnesses come with this. It's a little clip-on thing that we found people were, originally we had this all hardwired, but people would manhandle the temperature sensor and break it, and rather than have to do a whole harness, we just made it so it clips on. So this is the alternator temperature sensor, okay? And then the next leg we have is for the battery. And this is, we've got battery sense wires, we've got gray and purple for the shunt, we have a battery temperature sensor wire. And I'm actually just realized that I've been talking through my next 4 slides. So those will go quick. And then this particular one has a CAN connection if that's how you choose to make your CAN connection. So let's go through these slides a little bit more detail here. So pin by pin. Wire number 1, we're on the panel side. Wire number 1, you must connect this wire up. And yes, I've had support calls where the customer said, this Wakespeed is broke, it's not working. I've connected up the power wires and it's not working. It's like, well, this is only part of the required. So yes, you must hook up the brown wire. That's what turns on the logic side of the regulator, okay? The feature out wire, mostly this is used to emulate, who in here knows what an idiot light is on a car? I'm glad to see a few hands going up. And notice I said the idiot light, not the idiot, right? The idiot light. So back in the day, the charger, there's a little light that comes on that says your alternator is not working. They were known as idiot lights because if that light came on, it probably meant your fan belt was broke, or some other thing was preventing the alternator from charging. We, by default, emulate an idiot light. So a lot of times what they'll do is they'll route that wire up to the helm, and you'll put a light bulb there. It's a grounding wire, so that orange wire goes to one side of the light bulb, the other side goes to a positive voltage. And when the Wakespeed wants to illuminate that bulb, it will ground that wire and complete the circuit. That's how you get the bulb to light up. By default, what we'll do is we'll turn it on for 2 seconds when you first apply power, because that emulates how idiot lights worked. And then from then on, it should be extinguished. Now, the one difference is, if there's a fault in the regulator, that light will come on, and we'll blink out the fault code. Just like you would see on the little LED, we will replicate that on the dash panel. So it's a very nice feature to install for the customer. It's a way for them to know, oh, something's gone sideways, and I need to look into what's going on. We also have the ability, if you're concerned that a customer will get confused by blinking lights, you can change that configuration so it just always turns on whenever there's a fault, and they'll have to go down to the engine room and see the blinking code on the LED. So, yes, sir?
So does that have to be an incandescent light?
No, it can be an LED. Just, keep it at half an amp. And, you can do 12, 24, 48. It's what's known as an open collector. If you think of a relay, right, it's the normally open side of a relay. So it's like nothing's connected, but when we activate it, we'll tie that side to ground. We're just connecting the ground, yeah. So the easiest way to use it, put a light bulb in your dash, one side connect to the orange wire, the other side go over to your ignition when the key switches on. That's usually how these things get installed. But they're also kind of nice in vans because, we mentioned that a lot of times these regulators are installed by the batteries. They may or may not bury them in a way where you can't see it. It's kind of nice to bring that little light out. And if you are going to do it, make it so that lights actually really bother somebody when it's illuminated. It shouldn't be one of these feeble, ones that you can barely see. If there's something that's gone sideways, this is the primary way that the Wakespeed can tell your customers that something's not right and it should be looked at. Okay? The feature in wire, we already talked about this. It's typically used, I think more often than not, it's simply used as a way for a BMS to communicate into the regulator. The other way that it is used, actually, is do you remember I talked about how the dip switch would select full power mode and small alt mode? There's actually a third mode in the regulator called half power. And these all got names, and no, you can change all the percentages if you want to. But another very common use that I've seen in the marine world is that people will put their toggle switch on the dashboard because they want to be able to depower the regulator. They want to only draw half power of the alternator because they're trying to maneuver, and they don't want to go through and set up the white space or any of the other features. They want to have a carbon-based control unit and do that. So that is probably the second most common usage I've seen for that feature in wire. It lets you select a different mode of operation for the Wakespeed regulator. Now, there's much more advanced options. We have some configurations where you actually have the system running 724, where the regulator is always powered on, and you end up putting the ignition into that. That's how the regulator knows if the engine's running or not. So there are more advanced features with it, but I think the two most common is BMS integration with some BMSs, and then and I only see this in the marine world, where the operator wants a toggle switch. They can say, I want less power out of that. Okay. Oh yeah, I should add, for this guy here, for the feature in wire, you just have to apply a positive voltage. Regulator doesn't care, probably anything above 5 or 6 volts up to 100 volts, it doesn't matter. Just any sort of positive voltage is fine. Yes, sir?
So when you say BMS integration with this wire, is it essentially the same thing as the remote shutdown pin on most Victron products where?
Yeah. Yeah, so like, for example, on the VE bus BMS, this is the wire that goes to a charge enable. And we actually invert its meaning, that if we don't see activation on this, if we don't see a positive voltage on this, the regulator will stay in standby mode. Links BMS the same way. Probably the number one complaint or service call we get around the Links BMS is they've not done the white wire correctly. And unless a positive voltage is applied to that wire, the regulator stays in standby mode. So you get the call, why is this thing not charging my battery? Well, there's why. Okay. All right. Next, alternator temperature sensor. We've talked about that a lot. Black and red, this is the power side of the regulator. Put a 10 or 15 amp fuse in. You just want to fuse it to your applying your field voltage to. And then the blue wire is what you actually connect up to the field itself. So again, the black and the red and the blue wire, those are required wires. Please hook those up. If you don't hook them up, don't make a service call, because we'll eventually figure it out and someone will feel silly. All right. Oh, yeah, and then the yellow stator wire, we've talked a ton about this. Yellow stator wire is a way to sense RPMs. If you are doing a configuration where the Wakespeed needs to know RPMs, such as white space, then that's one way of getting RPMs into it. I'm sure people who have done installs for a while, you know the classic customer complaint of, my battery charged and my tachometer stopped, what's wrong? And we touched on this briefly earlier. It's because when the battery's charged, you're not exciting the alternator, so the alternator's not producing any power. It's not producing that AC waveform, and that's what the tachometer is driven off of. It's gone back forever. Back in the lead acid days, I think my partner Rick's, his statement to customers is, well, do you have a microwave on board? And they say yes. And he says, well, go make some tea and just put a load on, and you'll have the alternator come back online to support that load, and your tach works. It's very problematic when the alternator doesn't have to produce energy to the battery, your tach goes away. And in the lead acid world, we had this feature where you'd say instead of going to 0, you go to like 2 or 3%, and that worked because lead acid batteries are forgiving. They just boil off more water. In the lithium world, that's dangerous. This, I think, is one of the most problematic aspects of doing systems installs. My recommendation, well, I've been telling people this, if you happen to have a dual alternator install, put the yellow wire on the factory alternator, the one hooked up to the starter, because this is always going to be active. Wakespeed doesn't care where it gets that signal from. It doesn't have to be the alternator it's connected to. We have, so if you've got an engine with a flywheel, Hall effect sensor in, with a pulse generator, put that stator wire to that. It doesn't matter. Wakespeed doesn't care where it's getting that waveform from, or if it's a square wave, or if it's a high voltage or low voltage. It doesn't matter. If you need to get RPMs in via that yellow wire, just find something that's stable. All right. Any questions on that? And have you guys been exposed to this whole issue of the tachs dropping when the battery's full? Yeah, a few people have. It's a classic thing. Yeah, white space, and we will cover this in greater detail tomorrow. White space is the ability to tailor how hard you drive the alternator based on RPMs. So if you've got a small engine with a big alternator on, it is going to struggle to drive that alternator at idle at low RPMs. So white space lets you say, when you're at lower RPMs, don't drive the alternator hard. You can create a curve. And you can say, and it's got a lot of really good uses. It's good for low end. It's good for planing to make sure you don't overload. It's also good for getting up on step for planing boats. There's a lot of really good uses for it. But we need to know the RPMs. Yes, sir.
There's a benefit to having your tach drop out. The hour meter also does not occur.
Well, unfortunately, on my personal vessel, neither of those things happen because I have a mechanical cable-driven tachometer, and the hour meter is triggered off of the ignition. So anyway, all right, moving on to the battery. So we have the battery temperature sensor. We will often recommend we want to know what the temperature of the battery is. And we do that for a couple of reasons. If you've got an old lead acid battery, there's something known as temperature compensation. The voltage you apply to a battery is different depending on the temperature. Chemical reactions happen more readily at higher temperatures. So if your battery is warm, you actually do a lower voltage. You don't bring it up to the 14.4, you bring it up to 14 something. If the battery is cold, you have to apply a higher voltage. Very common parameters known as temperature compensation. It's usually something in the order of 30 millivolts per degree C per 12 volt unit. So that's one of the reasons why we want to know the battery temperature. You will hear in the best resource in the world, AKA the forums on the internet, that lithium batteries don't need to have battery temperature sensing because we don't do temperature compensation. Well, they're right about the latter. You don't do temperature compensation, but there's a reason to sense the battery temperature. If that battery gets too hot or too cold, the Wakespeed will stop charging. I don't recall if I said already, one of the support calls we started getting in was people in New England. I think I did mention this, right? In New England, in November, when it's 20 below zero outside, we wouldn't charge that battery because we had the temperature sensor attached. So I encourage you to always install a temperature sensor, either a dedicated one like this, or if it can come in over the can, let the Wakespeed regulator know what the battery temperature is so that we can preclude damage happening. Yes, sir?
You've got a battery bank. What's the best place to attach that sensor?
Oh, that's such a loaded question. And the answer is yes. I don't know the answer. Pick some place that's representative, somewhere in the middle of the battery bank maybe. We have found with lithium batteries, if we don't get the temperature, if we're using an analog temperature sensor with lithium batteries, typically the positive post is better, especially with ones with built-in BMSs, because the BMS usually switches the negative aspect of the cells. So if you attach to the negative, you're going to end up knowing what the temperature of the BMS is, not necessarily the cells. The other thing that we have, that I actually learned here just a couple weeks ago, when you've got a large number of lithium batteries in parallel, they'll all be their own achiever. And you could find up a 10-degree delta on the positive post between different batteries, depending on where they are in their own balancing and state of charge. So the thing, if you really want to get into it, and this actually came about because it was a customer in a van in the desert. And he said, God, it's hot out, but you know, it's not that hot and my battery isn't charging. You know, he was at like 30, he was like at 90, 95 degrees C, right? So that's like around 30 degrees centigrade. So not, yeah, around 30 degrees. So not at the limit, but because of the battery he chose and because the batteries normally heat up, the one battery, by luck of the draw, was the warmest of the whole bunch. Now, in that particular case, we consulted engineering, and they recommended, because the customer had taken detail on each battery, they recommended put the battery temperature on one that's more in the middle, representative. What happened in that very specific case is that warmest battery, when he reached his limit, he turned off, but the other 7 batteries were still there, and we continued charging the other 7 batteries. So the system worked well and safely, but the problem the customer was having is just by chance he picked the battery that was the overachiever of the bunch. Okay? The purple and the gray, those are analog sensors for battery current. They are traditional shunts, you know, just shunts like you all see. Just hook up the purple and gray. You heard before, a big value of the Wakespeed is we listen to the battery, let the batteries tell us what it wants, what it needs. This is an important connection. Make sure that the Wakespeed regulator can get battery current, okay? Now, let's see, what do we got next? Speaking of shunts. Speaking of shunts, there's our shunt. So, classic example of the shunt, and I'm just going to give you my little personal hint. This is a drawing that you'll see often in our manuals. The Wakespeed regulator allows you to place the shunt on the positive line or the negative line. When you do your install, please read the description where it says, use the shunt required. In other words, pick one. Yes, we do get support calls where people are saying, how do I hook up my two shunts, one high and one low? You don't do that. You just pick one. This is showing how to hook up the gray and purple wire to the shunt, depending on whether you've installed it on the positive line or the negative line. In the real world, most battery systems I've seen, it's in the negative line. If we are getting battery current in a different way, such as over the CAN, then that gray and purple wire is not used. People will install a shunt on the positive output of the alternator, and that's how you would hook it up in that way. Okay? So that comes back a little, that is all we have in terms of how the wires for the Wakespeed regulator. It's you got to hook up to the battery, hook up to the alternator. Really, if you look at AR Solutions, about the only difference we have is there's current shunt. And I will tell you, as we go through and start doing some real-life examples of how to hook up the battery to specific batteries to the Wakespeed regulator, some of this information comes over the CAN. So if we're getting battery temperature over the CAN, you don't need to hook up the battery temperature sensor. If we're getting battery current over the CAN, you don't need to hook up the battery, the current sensors. Yes, sir?
So can you share the shunt like the Victron shunt?
Yes, you can. Okay, I'm going to try to make this little laser work. Oh, look at this. So here is where you connect your high power current cables there. That's where your, 4-aught wires go in and out, right? These little side terminals here is where you hook your sensors to, sensor wires. Never, ever, ever connect these sensor wires to these high power currents. And the reason why is we are measuring microvolts. I mean, it is a very small voltage. Just the current flowing through those high power terminals will introduce a multi-amp offset, and you will get no accurate reading. So, number one hint, not your question, but number one hint, do not install the gray and purple wire there, put them here. Now, coming back to your question, some Victron shunts, you can see those little screws. Go ahead and connect up. Won't be a problem. Some shunts, they put a plastic cover over it and you can't see it. At that point, you can do one of a few things. You can pry the cover off. You can actually drill and tap holes on the back side of that block and put in your own little screws, or you can install a separate shunt. And I've actually heard of all three being done. Most installers, they just won't mess with it. They'll just put a second shunt in line. Okay. All righty. I want to go and talk about some of the other accessories that we have now. I want to talk about temperature sensors. This is an example of a temperature sensor. We offer this in different lengths. This is 1 foot, I think it's 0.3 meters is when you order it. We also offer it in a 3 meter and 10 meter. So, short, long, and really long. They are exactly the same. Doesn't matter if it's used on the battery, doesn't matter if it's used on the alternator, the technology is actually the same. And actually inside here, that's another thing. Please don't be cutting this off and crimping on a bigger terminal because there's actually the sensor inside here. This is actually what a 10K NTC, negative temperature coefficient temperature sensor. You can check these in the field by using your ohm meter and get in on those pins. And it's kind of hard to make contact. You have to kind of work out a little bit, and don't pin the pins, but you should see around 10K ohms on your multimeter at room temperature. If it's hotter, it's going to be a lower resistance. If it's lower, it's going to be a higher resistance. But that's a quick field check to know if you've got a hosed up temperature sensor. The other hint for these, temperature sensors is they are susceptible to noise. So if you're doing a long run against something that makes a lot of noise, you can introduce artifacts and come up with artificially wrong temperature sensing values. The most common thing that we have seen is people will use along one of these. They'll go ahead and put the regulator back by the battery, and they'll extend the blue and yellow wire up to the alternator, and they'll put the temperature sensor right next to it. That will couple This is a high power signal. It'll couple from here into the temperature sensor and corrupt the readings. You can do two things. You can either separate them by about 3 or 4 inches, or more commonly what people do is if you take this harness, if you take this here and just cut this right here and crimp on your extended wire and use shielded instrument cable. So you've got maybe 15 feet going up to the alternator on this blue wire. Put 15 feet of shielded instrument cable. Make sure you ground the shield on one side only, best practice. Then crimp this thing on the other end and plug this into the alternator. That works really well. Okay. CAN. Controller area network needs three signal wires, a CAN high, CAN low, and a ground reference. They are all behave the same, but there are, unfortunately, different wiring standards used. The single most common wiring standard that you're probably familiar with is NEMA 2000. Have you guys covered NEMA 2000 NEMA yet? Not yet? Okay. So NEMA 2000 is a way for different instruments. It's a way for your GPS to talk to the chart plotter. Digital communication. And that is the most common wiring system you'll find. And it has a connector that looks like this. This is a NEMA 2000 connector. The other most common one that you'll probably run into is the RJ45. And that RJ45 is used with a lot of Victron equipment. So that is where you would use these type of connectors. Looks like a computer cable. And you would plug in to here. The third standard that we support, actually we support another standard. We support a RV industry standard. So on the CAN harness, I made mention that there was an extra connector. This guy here. This connector on the end is an automobile standard. If you go and open the hood of your car, you're likely to see a bunch of these. Also, just for reference, green and yellow is an automobile standard. When you're hooking up the yellow wire to your alternator, don't hook this yellow wire up. Hook the wire that comes out of the alternator side, or the alternator leg, right? So this is an automobile standard, and those are the two primary ways that we can get CAN out of the Wakespeed regulator, the RJ45 jack or through the harness. And if you're taking it through the harness, if you're going into the RV world, they'll have a backbone that they'll plug this into, or you can get this adapter, clip onto here, and that becomes your NEMA 2000. Makes a really tidy install for Wakespeeds. We also make some battery-specific adapters. Here's, for example, an adapter that goes with Lithionics batteries. It clips into here, and then this goes to the Lithionics proprietary BMS connector they use. You can also daisy chain these if you want to have more than one. So we offer, unfortunately, we have to offer multiple CAN wiring standards. So for your install, my recommendation is start with your battery, start with your BMS, start with your instruments. And really the primary choice I think you're probably going to typically make in the marine world is, are you going to do RJ45, which means you're probably largely Victron, or are you going to go to the NEMA standard? And that choice is going to be made on whether you want to have the Wakespeed present its information onto NEMA displays. A lot of people do. In that case, I would suggest a very tidy install is get this adapter from Wakespeed and clip it in, and then get a similar adapter from Victron and clip it in and use NEMA 2000 for your wiring standard. Yes, ma'am?
Is NEMA 183 compatible with the NEMA 2000 connectors?
Is our what?
NEMA 183.
No, no, they are totally different. Yes. Yeah, good question, but no. NEMA 183 was before the CAN protocols became available. It accomplished a similar function. GPS talk to your chart plotter. On my personal vessel, that's what I use. But really NEMA 2000, the CAN-based stuff, this type of connector, for the past 20 years is what they've had. Okay. I think that's about it. Okay. What I want to talk about now are some representative install diagrams. Do you remember how I told you can go to the Wakespeed website on the support tab, you can download PDFs? These are some of the PDFs that you can download from there. And we're going to go through each of these. I picked these three because this is an example of a legacy install where we have totally independent temperature sensing. We have a current shunt for sensing the current. This over here is an example of a CAN-based install where oh boy, somebody edited this stuff and moved them around. Sorry. This here is an example of the other extreme, where we've got a CAN-based install, and you notice we don't have a temperature sensor to the battery. And we don't have a current shunt, because we're getting that all over this CAN connection that I just showed you, right? And here's an example of using a optional harness that we have. And I think, yeah, we'll cover that when we get to it. That's this particular harness that's typically used in van installs. We call it our van harness. Its biggest difference is it's simplified the amount of wires that you hook up on the battery side, and then it's got this big, long 27-foot leg that goes up to the alternator, goes to the alternator, and also goes to the alternator temperature sensor, and has the shielded cable end. If you can use this, this saves you a ton of time and a lot of crimping, and just makes your life easy as an installer. All right, so let's go ahead and go through some of these. So this is a legacy install, and what we are doing is we're using analog sensors. So remember, you got to hook up the two ground wires. Those are required. You have to hook up the brown ignition. You have to hook up the blue field. A lot of the other wires are optional. I suggest you hook up the battery current. Even though it says suggested, I'm going to say that's required. The regulator will work without those, but it becomes just a voltage regulator, which is the stuff we've had for 40 years. So if you want to make your Wakespeed regulator behave like every other alternator regulator out there as a voltage regulator, don't hook up these extra sensor wires. But the moment you hook them up, then you'll get some of the capabilities of the Wakespeed unlocked. And then we already talked about the optional, the feature out wire. So you can see here, we've got our batteries hooked up. They're all connected in parallel. We've done the good best practice of the opposite corners, right? We've got our fuse, we've got our service disconnect, and then we've got our bus bars. This is how we typically see these products installed, that you'll have the red and black wires go to the bus bars. Now you can have, depending, if this thing is located very close to the alternator, you could put the heavy power wires, and you'll see in our documents where it'll say connect to the alternator. That red and black wire could actually connect here, and then the red and black with the yellow stripe wires would connect to the bus bars to get voltage sensing. But as I mentioned, more often than not, what we're doing is we're seeing this thing, the Wakespeed established near the batteries, so it's very common to run these here. Then we've got the lamp, the orange wire to the ground side of the lamp. It's not shown, the other side goes to some positive, and then your key switch, when it's turned on, that's what turns on the regulator. That's pretty much it. That's probably the most complex wiring install that you'll ever find with a Wakespeed regulator. Yes, sir?
That's a good example of both lead acid and drop-in lithium batteries.
Yep.
So this, you know, if you were doing an AGM system, this would be kind of an ideal layout.
Where are the shunts in this?
Right there.
Oh, okay.
That's the shunt right there. Yeah. Which, by the way, one of the good things about installing the shunt on the low side is you don't have to fuse it. If you're going to put the shunt on the high side, you know, best practice is going to say you're going to put fuses in, and that just increases complexity and stuff. This is the fundamental. This is how my personal vessel is set up with 2,500, well, it used to be 2,500 pounds of lead acid batteries. Right now, after a couple of my son-in-laws cursing at me for having a really good battery box, it doesn't have any batteries in it, but that'll be fixed. But this is how my vessel was installed and set up. Like I say, pretty straightforward. About the only additions you do on our product versus some traditional ones is you have to add the current shunt wires. All right, we have talked about the P harness, which is the most common harness that we sell. We have talked about the P CAN harness, which is exactly the same, except it has a fourth leg for CAN bus. And we also talked a little bit about why you would choose this harness versus the standard one. I want to show you the van harness. And this one, I got asked the question here, how many of our regulators go into marine versus RVs? Show of hands, who thinks it's around 50-50? Who thinks it's 70-30? Oh, I have to tell you that? Either one. Who thinks it's like 90-10? And who of that 90, have I already told you this? Who of that 90-10, did I? This has nothing to do with listening, this has to do with CRS. I'll tell you what that means when I'm not being videoed. All right, so yeah, by and large, more of our regulators go into the RV industry or anything else, and a ton of them go into these Sprinter vans. Sprinter, Ford makes them, the Transit, the Dodge makes them, there's ProMaster, there's different variances. But it's a very, very common installation. So we created this van optimized harness for that purpose. You've got the same connector that goes back, plugs into the alternator regulator. You've got your same brown wire that goes up to the ignition, except this one is 18 feet long. Because guess what? The ignition's up by the driver's seat. So you don't have to splice on extra wire for this. We have the same red and black wires. We have the same purple and gray wires. We have the same white wire. We don't have the yellow wire because the van installers, usually you can see the regulator and they said, we don't need the yellow wire. We needed the white wire because some of the BMSs we talked to, that's our feature input. And you'll notice we have a red and black wire and only one pair. There's not two pairs of red and black wire. We actually combine the two pairs of red and black wires inside the harness, inside the connector here. So you only have to hook up these two wires. A little bit of loss of efficiency because we're sensing voltage over the same pair that we're pulling the high power for the alternator, but this thing's only 4 feet long. So the loss, the delta, the inaccuracy or reduced board is nominal. The cleanliness of doing your install is a benefit. You'll also notice that none of this is in the sheath. That's because it lets the installer optimize and tune the wire lengths as they should be. Then we have got a battery temperature sensor with the blue, and we've got a CAN connection. The reason why I like this, and if you can use it, I would encourage you to consider it. The reason I like it is because you don't have to do any butt crimps. You don't have to extend wires. We already have the shielded cable for the temperature sensor, the alternator temperature. It's all taken care of. So it just makes a simpler, quicker, more reliable, because this is done in an ISO certified factory and tested. This stuff is highly reliable. You don't have to worry about field button crimps or anything like that. So that is the van harness. And there we go. M12 adapter, we've already talked about it. You will see us use this nomenclature, M12. M12 is actually the technical spec for this connector. Prior to joining the Dragonfly Energy Group, Wakespeed was not a member of NEMA. We were not allowed to use the word NEMA or NEMA 2000. Those are copyrighted terms. And we hadn't paid the fee to join, for a number of reasons. But now, Dragonfly, we are full members of NEMA. I actually sit on the NEMA boards and stuff. So we are moving our nomenclature in our document to say NEMA 2000. That's what this connector is. But if you find some old documents of Wakespeed, you'll see it called an M12, or sometimes you'll see it called DeviceNet. This actually was originally, this wiring standard was actually defined under a DeviceNet standard, and NEMA adopted it for their own use. So I'm only telling you that because if you find some of our older documentation and you come across, well, what's an M12 or why is it a DeviceNet? Those all mean NEMA 2000 once you paid the licensing fee and are a member of the company. Okay? We talked about the lithionics CAN adapter. This is the DTM connectors industry standard. Another thing that goes with this, and good Lord, it's missing, there's a terminator that clips in the end on here. And I don't know why I don't have it here. CAN needs termination, so part of this wiring system, if you use it, is you would either daisy chain a couple and then put a terminator on the end of the daisy chain. Okay? The other CAN wiring option we have is this, RJ45. Very, very prevalent in the Victron world. They're VE CAN bus connectors, or RJ45. You'll notice there's a blue end and a black end. Blue for Victron, along with the blue terminator, and black end for Wakespeed, along with a black terminator for here. This is what I say. The pinouts are different between Victron and Wakespeed. Wakespeed chose to use an international published standard called CIA 303. Victron chose to use a Victron standard. Actually, they didn't. There's a beer story about how they got there. But the bottom line is the two standards are not compatible. If you look closely at this cable, and we have, if you go to that Learn tab, there is an integration guide, a little guide on how to do Victron. It calls out the wiring. You can buy these cables pre-made, black to Wakespeed, blue to Victron. You can make them up yourself. There's only two wires, CAN high and CAN low. And we go from like pins 1 and 2 to pins 8 and 7. So it's opposite ends and they're crossed over. But you have to use a crossover cable or it won't work. And by the way, if you want a whole lot of fun, plug one of these things into a Wakespeed, especially on a 48 volt system, and life will get interesting. Actually, I recommend you don't do that, but that's a level of detail you need to know about. So when it comes down to CAN, and we belabor CAN quite a bit because CAN is an important method for all of these guys to communicate. The batteries, the BMSs, the monitoring, there's a lot of good stuff that can happen with the CAN subsystem. You have to know what wiring system you're using, and we offer the flexibility with a variety of them, but you gotta order the right part. Remember, I started out after lunch, your best friend is the Wakespeed Buyer's Guide. That's what the Buyer's Guide is going to walk you through. It's going to bring you down and say, hey, what kind of CAN connection are you using? Here's the stuff you should consider buying. Okay? Any questions about this? And I know it's all new, and hopefully it'll sink in a little bit, but at this point, do you kind of think you have sort of an understanding about how you might approach buying this stuff? Okay. My primary recommendation is figure out what battery you're using and then go from there. That'll tell you how to pick up the CAN. For the marine world, I would say, you guys, if you're going to do installs, you're either going to do a Victron-centric one with this, or use the NEMA 2000 adapter and use NEMA 2000 backbone. Okay? And that's going to be driven primarily about whether your customer wants to see Wakespeed information on their NEMA 2000 display. If they do, just go this way. Forget the RJ45 with Victron. Get the Victron's NEMA 2000 adapter cable and just use this. It's a nice, really clean install. All right. All right, what do we got next? Temperature sensors, we've already talked about this. They're all exactly the same. The technology, they're all 10K ohm. It's just different lengths and you can order it. I think our lengths are specified by meters. I think it's 0.3, 3 meters, and 8 meters, something like that. But you know, just pick the right length temperature sensor you need. Or if you want to extend it, that little trick, actually Rick came up with that trick. If you want to extend these things, just cut the harness cable here and butt splice in your extension wire. That way you have the connector on the other end, and just pick up a short, you know, just use one of these short temperature sensors. And if you're in a noisy environment, remember you want to use instrument cable, shielded instrument cable. Does everyone know what I mean by shielded instrument cable? All right, perfect. So Ancor makes it. It's called instrument cable. It is a 22 gauge wire, red and black, twisted pair, and it's got a metal braided shield around it. And it's used for sensitive, noisy environments. The shunt is a sensitive sensing signal, so if you're going to extend it, you want to use shielded twisted pair cable. The temperature sensor we mentioned can have noise interjected into it, so I use shielded twisted pair cable. You hook up the two wires to that red and black, polarity, and then the shield itself is a metal braid that acts as like kind of an electrical protectant around it. Connect one end of that shield. When you strip it off, you'll actually find a braided or a foil metal shield, and there'll be what's called a drain wire. That's just a bare wire. It's actually a third wire. Connect that drain wire on one end only. The other end, don't connect up the shield. If you connect both ends of the drain wire at the ground points, you've basically made it not a shield, but actually an antenna in the bad way. So that's what shielded instrument cable is. Ancor makes it. It's just if you go and buy it, you'll find it readily. To install it correctly, do that shielding grounded on one end. I usually pick the quieter end. Sorry, did you have a question?
Yeah, I have a dumb question for clarity. You're talking about electromagnetic noise, not...
Yep.
Okay.
Yeah, not audible noise, but it's induced noise from EMI, EMI-induced noise. Yes. Yes, sir.
Inside the sheath of the Wakespeed harnesses, is that a twisted pair that is connecting to the shunts?
Sometimes. You'll notice this isn't.
Yeah.
I would be inclined just to wrap them around. The evil of good is better. I don't know, to be honest with you. I think these harnesses are supposed to be twisted in some way inside. I think they are. You can kind of get away with some things in a short distance, but it's when you get longer distances, you want to be a little bit more careful. Okay. Any other questions? Oh, these are wicked cool. These little things here. So if you look on the white box, the RJ45 sockets, you'll notice that there is a threaded outer pipe type thing. We sell a couple of accessories. If for some reason your customer wants these to be dressed up and covered, you're not using them, you can buy these little dust caps and just thread them on there to cover it up. Now keep in mind, these things are epoxied and waterproof. Isn't really necessary. If you're going to get a lot of gunk inside there, you might short out some signals. So yeah, if you're not using them, get a black box or put a cover on it. But this, and I wish I'd brought an example. Remember I told you can make these cables up? Anybody who is in the computer industry knows how to make Cat5 cables. It's just run of the mill. They eat their cereal in the morning and they churn out Cat5 cables right after that. These kind of little cool things, there's the little connector, and then there's an outer plastic shell. So normally when you make a Cat5 cable, you just use this. That's this little clear plastic part and then maybe a rubber boot on. But we offer a water type accessory kit that has the same little clear plastic guy. And then the outer boot actually screws onto here. And what I really like about it, to be candid, is not necessarily for the waterproofness, but the cable comes out through the other end, and there's another little screw-on gasketed O-ring thing. What's nice about it is it gives support. You know, this guy here, it's just hanging off of this. That little cover, and they're not too expensive. I think they're like $6, $7 each. They're not so expensive. You put that little cover on, and you get a nice, tidy mechanical support that comes out of, all of this stuff here is contained within that little shell. And you got a nice little mechanical support thing, and that's what the customer sees. Really, really makes a tidy install if this is the wiring method you're going to use. That's it. Again, I thank you very much. I appreciate your time and attention, and I'm sorry to drone on for what is probably much longer than you're used to, but I do hope you have found it valuable. Okay.